Ladies and gentlemen, we are now entering the main agenda, which is the presentation and discussion session. This session will be moderated by one moderator from each university. From Oregon side, we have Dr. David Stone, which is the Associate Dean of International Program of Food Innovation Center. And from IPB side, we have Dr. Aziz Bolong-Sitanggang, which is the Deputy Director of International Program Services. So without further ado, please, Dr. Stone, the platform is yours.
Thank you very much. And thank you for those comments earlier. I can't agree more that this is a great opportunity between Oregon State University and IPB, and I look forward to the continuing discussions. And I just want to quickly say that, Oregon State University's mission includes advancing the science of sustainable Earth systems, improving health, human health and wellness, and promoting economic growth and social progress. And we really, I think the researchers you're going to hear today and the spirit and how we do our work and our collaboration really is committed to those overall goals. And so again, thank you to the partners in IPB. Thank you to my colleagues at OSU for spending the time today, which I hope will be a fruitful and productive long-term collaboration between our two institutions. So with that, I will kick us off by our first speaker is Dr. Gail Longoletto. I've had the pleasure of knowing Gail for many years now. She plays many important roles in our College of Agricultural Sciences and is a professor in the Department of Horticulture. So Gail, if you have do you have slides to share, or you do? Okay, so I think you should have rights to share your screen, and please take it away.
Thank you, Dave, and thank you, IBP University, for the opportunity to talk to you today a little bit about some of the research that I'm doing here at Oregon State University. One of the things that I do at Oregon State is I'm the principal investigator of what we call the Garden Ecology Lab. And what we do in the Garden Ecology Lab is we study plants and pollinators and really the people who manage garden spaces to try to understand how to make them more ecologically friendly and spaces that contribute to global ecosystem services in urban areas. I'm specifically interested in gardens as a unique green space in urban land areas. The topic of urbanization and the rapid urbanization of the globe are oftentimes associated with negative impacts on biodiversity and negative impacts on ecosystem health. But gardens potentially are one exception to that generalization. When we think about the value of gardens in urban landscapes, they represent large expanses of green space and can represent more than 50% of the urban green spaces in some cities. Several researchers before me have studied the expanse of urban gardens in cities such as Chicago, Illinois, Portland, Oregon, and Madison, Wisconsin. And when they use Landsat satellite images to count up the number of garden spaces across the city, they collectively counted thousands or tens of thousands of gardens. And when you add up each of those individual spaces together, they add up to tens or over 100 acres of land. So it's not an inconsequential piece of land type. Although each individual garden might be small, collectively they matter quite a bit. And I've really become interested in gardens as a way to contribute to urban ecosystem services, particularly after I read this paper by my colleague David Lowenstein out of the University of Chicago. And what David and his colleagues did is they made what they called these mobile pollinator gardens. So they put plants on a rolling cart, and then they would park this cart around different neighborhoods of Chicago. And then they would sit and watch how many bees visited the plants in those mobile pollinator gardens. They also had pollination-dependent plants in those mobile gardens, and they were able to measure pollination services delivered in each neighborhood. And what they found was that the highest bee abundance, the highest bee species richness, and in fact, the highest pollination services rendered were in the most densely populated neighborhoods in Chicago. And to my knowledge, this is really one of the first demonstrations that human population density has had a positive impact on an ecosystem service outside of the services of cultural and recreation services. And really the mechanism that was conferring these ecosystem services was gardens. Where you have more people, you have more gardens. Where you have more gardens, you have more flowering plants. And where you have more flowering plants, you have bees. My own academic training is that of an entomologist. I study insects and am an insect ecologist by training. So the work that we do in the garden ecology lab is broken up into 3 major topic areas. First, leaning into my academic training, we study garden insects, specifically the biodiversity of insects, particularly beneficial insects in urban garden spaces. We also study plant pollinator interactions and the potential for insects to move from garden spaces into nearby agricultural lands where they might confer pollination services to pollination-dependent crops. Second, we have several studies on native plants, looking at novel native plants for Pacific Northwest gardens. We're trying to understand how the development of native plant cultivars through the act of plant breeding impacts beneficial insects. And we're also trying to understand gardeners' perspectives of native plants and if we might be able to shift those perspectives so that more gardeners would be willing to include native plants in their home garden spaces. And finally, we also study garden soils. We look at the fertility of urban garden soils, contamination in urban garden soils, and compare them to published agronomic recommendations. And more recently, we've been studying how the act of gardening itself works to influence the human microbiome. And I'm going to talk about each of these topics in just a little bit of an overview. So first, with garden insects. My lab group has studied garden insect biodiversity in several cities, including New York City, the suburbs of New York City, and in Portland, Oregon. And even in some of the most densely populated areas of the globe, such as in New York City, we find a substantial amount of bee biodiversity, very high bee biodiversity of 110 species of bee in the New York City suburbs, and almost 100 species of bee in Portland, Oregon gardens. Now, the reason that I'm really interested in urban garden bee communities is because we have found that the ecological traits of the bees that you find in urban and suburban garden spaces can be comparable to the ecological traits and bee communities that you find in more protected nature reserves. So here in this particular comparison, we found 110 species in the New York City suburban gardens, which was comparable to the number of bee species found in a nearby nature reserve, even though the gardens that we sampled collectively only summed to 6 acres, whereas the nature reserve was over 1,500 acres. The percent native bees, the percent soil nesters, and the percent social parasites, which is a measure of bee community health, were comparable between the garden sites and the nature reserve. Really, the only meaningful difference that we found was that the nature reserve had a higher proportion of bee specialists. But still, to us, it was pretty impressive that on only 6 acres of land, there was an intact bee community that largely resembled the bee community in a much larger nature reserve. I'm also interested in urban garden biodiversity because even though we study green spaces in some of the most densely populated regions of the globe, we found that there are still new species to be discovered and described. When we did our work in New York City, we actually collected a bee that had never been described by science before. And in fact, this was part of a larger study looking at bee biodiversity in New York City, where 4 new species of bee had never been discovered and described before this time. I'm also very interested in garden bee biodiversity because we found from our sampling of Portland area gardens that you don't need a lot of space to make your garden a very attractive conservatory for beneficial bee species. What you see here is a satellite image of Portland, Oregon, and where that dot is one of our study sites. One of the things that I want to point out is that this study site was very close to a major highway, the I-5 corridor. And on 3 sides of this particular garden, they were surrounded by high-rise motels and apartment buildings. Even though this site was only 0.1 acres in size, because of the decisions that this gardener was making, they had the second highest bee species richness of all the gardens that we studied, and they had some of the most abundant bees as well. And it's notable that the sites that had higher bee species richness were 40 times and 100 times larger than the site that we studied. Now I'll quickly go on to our overview of studies of native plants. Had a recent PhD student that was looking at bee visitation and insect visitation to 24 Pacific Northwest native plants, and for non-native comparisons that were very popular in home garden spaces. This is just an overview of his study site where he had 1 meter plots separated by 6 meters on all sides. And over 3 years, he looked at plant phenology, insect abundance, insect diversity, and gardeners' impressions of his study plants. This is a quick summary of the plants that were most popular with bees as measured by bee abundance in 2017, 2018, and 2019. What I want you to notice is that the plant names that are highlighted in red are non-native to our region. This particular overview includes all native plants that were most attractive to bees if we include the non-native honeybee, Apis mellifera. If we subtract Apis mellifera out of the data set, we get a very different picture. The top 5 plants in terms of bee abundance for native bees were all the native plants to our region. We've translated some of this work into graphics that help gardeners choose plants that are most attractive to bees for their region. In this particular graphic, we have a non-native plant, lavandula or lavender, in the very center, because lavender is a very popular garden plant in the region where we garden. And then we have the number of bee species found on the top 10 study plants. And you can see that even though lavender was a plant that attracted a high abundance of bees, most of the bees that lavender attracted were non-native honeybees. And in order to truly get native bee species richness, we're recommending that gardeners choose some of these native plants. The study that I just shared with you gave rise to a second study where we are looking at native plants and their native cultivars. A native cultivar is a plant that has been bred to express showy traits that might be more attractive to gardeners, or so that it fits better into nursery production systems. In this particular graphic, we have the native plants that were the focus of our study in the larger circles, and then the cultivars in the single italices in the smaller circles next to each one. Now, we know that plant breeders are breeding native plants to make them more attractive to people, but we were really interested to understand how these changes might impact bee visitation. We're measuring several things about the native plants and the native cultivars, including color, petal size, plant habit, bloom longevity, just about anything you can think to measure, even nectar and pollen content. But one of the innovative things that we're looking at in this particular study is we are using camera filters to simulate bee vision to try to understand better how plant breeding not only affects how a plant looks visibly to us, but how a plant might look visibly to a bee. You may or may not know this, but bees actually see very well in the UV spectrum of the light wavelengths. And they specifically hone in on spots of high UV fluorescence as a way to better locate where pollen and nectar are located within a flower. So here we can see baby blue eyes, Nemophila menziesii under human vision, and then it's cultivar penny black. And we can see that under human vision, we have the very characteristic center bullseye, which tells the bee to go visit the center of that flower to get nectar and pollen. And then those signals are totally disrupted with the penny black cultivar. Just a couple more examples because I really love these photos. They're quite fun for me to look at. Here we have the native plant Clarkia ammoina under human and simulated bee vision, and we can see that the cultivar aurora looks quite different. And perhaps one of my favorite, the California poppy, Escholzia californica, which does not offer bees a nectar reward. It only offers bees a pollen reward. You can see for the native plant under simulated bee vision that the anthers are glowing fluorescent UV because that's where the pollen is, that's where the reward is for the bee. But the purple gleam cultivar, we see no fluorescence of the pollen, and in fact, we have a fake bullseye, which might trick bees into visiting that flower, and they would get neither a pollen nor a nectar reward. Now the next graph, this graph that I'm showing you is very busy, so I will try to walk through some primary points.
And
Here
Gail,
we haven't.
Yeah, real quick, a 2-minute warning, just FYI.
Oh, okay. So the study is ongoing. What we found basically is that when you have cultivation of native plants to produce cultivars, in almost all cases, we have a reduction in attractiveness to various insects. The one exception is Douglas aster, where we actually see an increase in attractiveness with the cultivars, and that is because the cultivars are very floriferous compared to the native plant. So I'll quickly talk about our work in urban soils. Briefly, we started testing urban soils because we teach gardeners a lot about urban soil health, and we wanted to know whether or not the soil characteristics actually reflect what we're teaching in our classes. And what we found was that there's a lot of evidence that gardeners are over-enriching their gardens in organic matter, as well as a variety of nutrients, including nitrogen excesses, phosphorus excesses, and excesses in micronutrients as well. We saw the same general patterns when we did a follow-up study using different gardens. And then I just want to end because I know that I'm running out of time, but we started studying if gardeners have their hands in the soil, does that affect their skin microbiome? We found evidence that yes, gardeners who have their hands in the soil quite a bit actually do impact their skin microbiome, but not everyone shows the same change in skin microbiome over time. This may be in part due to the unfortunate timing of this particular study, which started in the early stages of COVID when everyone was washing their hands all the time. And I'm so happy to be here today. Thank you for the invitation. I don't want to take more of my time than I'm allotted, but please feel free to reach out to me at any point if you have questions or would like to chat.
Gail, thank you so much. We do have a question in the chat. And if we have time, I have a question for you too, based on that, but thank you for that presentation. So the question on the chat is from someone at IPB that's wanting to wondering about increasing the yield of horticulture in the cities with the farmers, because it's impossible or almost impossible to bring farmers into the center of the city because there's not enough land to produce a product. So any comments on production or yield, or hopefully I got the sentiment of that question correct?
So if there is not enough of an opportunity to bring farmers into the middle of the city, what some researchers in the past have done is they've actually used satellite imagery to really map the city and see whether or not that in fact is true. If there are any opportunities to maybe cite urban agricultural production areas in tandem with schools or churches or other green spaces that currently aren't being utilized for agriculture, but you may be able to layer agriculture into those spaces. And that's also a shout out for a new project we're just launching in July, where we're looking at building integrated agriculture, how to better integrate agricultural production into high-rise apartment buildings from inception, design, construction, and then maintenance.
Excellent. Any questions from the audience or participants online or in IPB? Gail, I had a question on the skin microbiome. Totally fascinating. Has anyone ever tracked whether that also can influence going from the skin and gardening into the GI tract and internal microbiome changes from gardening?
Hi, Dave. Yes, we're actually starting a project on that just now, supported by NIH, where we're really just seeing whether or not gardeners that are consuming produce that they grow in their own gardens versus produce that they buy at the market, whether that action influences their GI microbiome, whether or not the skin microbiome transfers to the gut. I think that is a consequence of, like, honestly, folks have studied like how often someone bites their nails can have an influence. But the skin itself going to the gut microbiome, I don't know as much about that.
Fascinating. So much work there. Oh, we do have one more. I think we have time for one more question. It's what about managing the product but selling to consumers?
That's a really great question. One of the things that we've learned when looking at urban agricultural systems here in the US is that an urban farm is never going to compete with a peri-urban or a rural farm, just in terms of the scale of production that's possible in more rural regions. An urban farm will never be able to compete. So instead, we encourage folks to look at niche products which aren't produced at scale in more rural regions or peri-urban regions. Here in Oregon, it's actually a big market for culturally relevant fruits, vegetables, and medicinal herbs that are not provided by the more large-scale rural producers. I'm sure it's very different in Indonesia and IPB, but at least in the scale and scope of what you're able to do in an urban farm in a city center versus a rural farm, you're never going to compete for economy of scale. So you have to start looking instead at what you can provide that the more rural regions can't provide easily.
Great. Gail, thank you so much. We're at 6:20, so Boeing, I'm going to turn it over to you.
Moving on to the next speaker coming from IPB University, we've got Dr. Surya Dharmatarigan. He's a professor at the Department of Soil Science and Land Resources. Dr. Surya will talk about green infrastructure and water-sensitive issues. Dr. Surya, please. You've got 15 minutes anyway. Thank you. You can start it, Dr. Surya.
Okay. Good morning and good evening for our colleagues in OSU. Thank you, Prof. Dev and Prof. Langgeloto, for interesting presentation. I would just like to know whether you have seen my share screen.
Yes, we see that, but can you please slideshow your screen?
Okay.
Thank you. Great.
Okay. I'm Surya Tarigan from IPB University. First of all, I would like to explain a little bit my research interest. My research interests cover both rural landscape and urban landscape, but focus on water ecosystem service. I think it is a good complementary to what Professor Langgeloto have explained to us regarding the pollinators. Actually, most of my research related to rural landscape, including, for example, right now we have an intensive research on the role of agroforestry and ecosystem services. Agroforestry meaning that we try to increase biodiversity on monoculture system to increase the ecosystem services. But I also involved in various research in urban landscape. In this opportunity, actually, I would like to show you one of our research few years ago regarding green infrastructure for water management. But as I mentioned before, a lot of research also we are doing now regarding ecosystem service in rural landscape include what Professor Langeloto also mentioned, how agroforestry influence the population of pollinators in agricultural landscape. As you know, our agricultural landscape is expanding very rapidly, but mostly in monoculture system. And one impact, of course, the population of pollinators, and we also did a lot of study in rural landscape regarding how landscape structure influence the bee population. For this opportunity, I would like to focus on urban landscape. Yeah, I think it will be a good complementary for what Professor Langeloto explained to us. So our study, one moment, it is about water sensitive cities. Probably water sensitive cities terminology is not very common. I just like to explain that as cities develop, urban water management are being confronted with increasingly complex and multifaceted challenges as societal expectations grow and natural resources reach the limits of sustainable exploitation. And also, on top of that, climate change and population growth are increasing important issue. So the term water sensitive city is used to describe a future urban area in which a water system that can cope with the very complex. Why it is very complex? Because social expectation grow, population grows, and also natural resources become limited. So this is a graphical representation of water sensitive city. On top of this graphic, we saw the expectation of society on water in a city. So it is also along with many variable population growth and expect more healthy water supply system. And below of the graph, it is water management response. So there are 6 stages here. Yeah, starting from water supply city, and the aim of the water sensitive city research is how we can reach this stage where we have adaptive and multifunctional infrastructure and landscape reinforcing water sensitive city. Just to get impression, cities in Indonesia, in which level it is mostly now. I would just like to show you some data from our research, which we studied here in Bogor and Greater Jakarta. IPB University in Bogor here, and this is Greater Jakarta. Water problem that we have commonly, it is about water quantity, water quality, flooding, and storage system. For example, in Bogor, the demand for drinking water is 3.1 liter per second. Sorry, meter cubic per second. And then we have less supply. So demand is higher than supply. It is not only in Bogor, but mostly in big cities. And regarding the sewer system, we also have a minimum infrastructure to cope with sewage. For example, here, only 1% of wastewater that is treated, and only 4% it is safely disposed, treated. Sewage, domestic waste, and gray water from urban city, a very limited facility to treat, and mostly it is unsafely disposed. So this is an example of water issue that we have in big city. So demand is higher than supply, and also sewage system is not very well equipped. When we look at the water quality, this is one river flowing through Bogor city, and we look at some parameters regarding water quality, like total suspended solid, pH, biological oxygen demand, COD, coliform. Most of the sampling points show that the parameter is above standard value. So considering many challenges in water system in a big city, our research look at on green infrastructure, how to cope with this problem. So we have as counterpart from green infrastructure is gray infrastructure. Gray infrastructure traditionally engineered concrete infrastructure. We focus on green infrastructure. Why? Because as already mentioned before, that green infrastructure not only deals with engineering aspect, but also include environmental, socio-cultural, and economic aspect. So the green infrastructure should cover all aspects regarding the water system in a big city. For instance, we expect that good green infrastructure design can cope with flood reduction, water quality, and also socio-culture aspect, human health, well-being, aesthetic, and it also can contribute to economic aspect where it can reduce future costs of gray infrastructure, reduce energy consumption, and local economic productivity. This is some.
Remind you that you have 3 minutes left.
Okay, thank you. An example of a green infrastructure that we found, like rain garden, constructed wetland. In our study, we even give example how we can spatially arrange all of this green infrastructure in one city near Bogor. It is Cibinong City. So, for example, we lay out constructed wetland. Yeah, I think constructed wetland also can improve the issue that Professor Langgroto mentioned before, how we can use it as a nectar source for pollinators. I think some more slide. This is a constructed wetland where we combine plants to purify wastewater and it improves water quality, wild habitat, increase groundwater recharge, and neighbor amenity. It is the wetland, constructed wetland. It is not only important for big city. We also have another wastewater problem in the rural area. For example, palm oil mill effluent, which is have a very high quantity, and wetland. Constructed wetland also have potential to be implemented in this area. So I would just like to mention some research needed to optimize the design of green infrastructure technology, plant species, performance, media specification, sizing, outlet design, and influence of dry period. Plant species differ in their performance, particularly for removal of nitrogen and pathogen, and to less extra phosphorus and some heavy metal. And also sizing is also need to be more specified to cope with local climate condition and also outlet configuration. This is all my presentation. Thank you very much for your attention.
Thank you very much, Dr. Surya. I would like to open the floor for the discussion. Is there any question coming from the Oregon State University side? Yes, please, Gail.
Thank you, Dr. Teragan. I really enjoyed your presentation. I was wondering, for the constructed wetland that you shared with us for the palm oil plantation, how old that wetland is, and if there's any knowledge that's been gained on maintenance needs, whether or not after the wetland is installed, how often do folks need to go in there to manage and maintain that space?
Thank you. So our research in this green infrastructure, especially in this collaboration with other institutions like formerly we call it LIPI and BRIN. Now the main finding is the types of vegetation that can grow well in this wetland and their ability to absorb pollutant. This is the beginning of our research, but we still to experiment the size. So in big city, we don't also have large land that is available for constructed land. So the size is also important. Regarding the oil palm effluent, which is also an important aspect to be further studied. It is in rural area. In rural area, of course, we still have a lot of opportunity to use free land. So this is the research that we are doing. So particularly regarding the plant species, yeah, it is effective to remove the pollutant.
Okay, I think you missed the question about how old is the wetland.
Oh, you okay? You mean the wetland that I saw you in the PowerPoint?
Right.
Yeah, it is still young, 3-4 years vegetation. So, but we have a lot of example, which is I'm not showing in my PowerPoint. So I think I hope I can answer your question more or less, Dr. Langgoloto.
Okay, great. Thank you, Pak Surya. Is there any other question? Okay, just one quick question, Pak Surya. In your presentation, you've shown to us that, especially in Bogor City, we've got higher demand than the supply. I would like to talk about the supply in here. Is it already the summation between the surface water and ground water?
In Bogor, yeah, in Bogor, the drinking water mostly from surface water, yeah, from the river. We in this data we didn't include the water from groundwater because our study site cover mostly in Bogor. In Jakarta, many people use groundwater.
Okay, great. Thank you very much, Dr. Surya, for your presentation. Because our time is up, so I would like to give back the opportunity to Dave.
Thank you.
Please. Thank you, Pak Surya.
You're welcome.
Okay, thank you, Boeing. So again, my honor to introduce the next speaker from Oregon State University's College of Ag Sciences is Professor Michael Chan in the Department of Food Science and Technology. And Dr. Chan is an expert at flavor chemistry and technology. He's worked on aroma and flavor compounds in wine, grapes, beer, hops, dairy, small fruits, and many other food and beverage products. So with that, please take it away, Dr. Chan.
Okay, thank you, David. Good morning, good evening. So whatever the time zone we are in. So it's here we have evening, and I have a very quick dinner already. I have a bowl of rice, and some of you probably see in my front of the camera. So I'm eating, I'm finished it. So now I have the time to talk about my research. Thank you again to give me this opportunity. And let me see. I should be able to. See if I share my screen. Okay. I hope that's the slides.
Yes, just if you could put it in presenter mode.
Yeah, I will. Is it okay now?
We can see your notes. Is there another the mode with looks like a projector screen on it? That button.
Stop sharing. I have two screens here. Is it better
Perfect.
now?
Perfect.
Okay. Again, so thank you again. I'm Michael Chan, a professor here at Oregon State University in the Department of Food Science. My research is heavily in the flavor chemistry, including a wide range of things in the berry fruits that I have been working on. We heard about coffee. Yes, we do work on coffee. But the majority of my research is working on wine and wine grapes. So instead of talking about a specific research project, I will give an overview. So here, what we are doing. Okay, the key pieces here, we are using the flavoromics type of approach. So what does that mean? It's we use a technique called the sensory directed flavor analysis. And by using this technique, we get the extract from any commodity product, either it's wine or beer or the coffee, to extract the volatile compounds. Then we inject it to the GC and mass spec. So in the system, we'll be able to smell individual compounds as they come out from the GC, and we use mass spec to identify the key compounds that are responsible for the flavor. Either this is positive, a lot of the time, unfortunately, we have to also deal with the negative, the flavor compounds, such as something associated with or flavor. And then what you can say, well, you say, why do we want to do this? Well, if we understand the detailed chemistry, and then we try to trace back and then looking at the precursors, looking at the either it's a thermal generation or either by enzyme, and looking for flavor precursors formation in the grapes, as well as the flavor generation or flavor formation in the food system during processing, or a lot of time during storage. So we can address this kind of issue. In the past 20 years or so, we have been continuously working on wine grapes, because wine and wine grapes are one of the most important commodity products in Oregon. We want to produce and continue to produce the premium quality of wine. As a result, the flavor research is very critical, it's very important. Well, in this kind of approach, we know the good wines can only be made from vineyard. So we started from vineyard and then look at different parameters, all kind of different parameters, environment, the sunlight, the temperature, the availability of water, so on and so forth, associated with the soil. All of this can have an input to the quality of the grapes, and finally, to the quality of the wine. Well, some of those factors we can control, such as the fertilizer, and some of them we cannot control. The temperature we cannot control, the amount of precipitation, as you know, in Oregon, we rain a lot. So the precipitation, wind, the rain, and we cannot easily control. So as a result, we go to the parameters that we can control, such as the viticulture practice. So we collaborate with research scientists in the horticulture, in the USDA, in other fields. So study different viticulture practice and look at water management, how much fertilizers we can apply to the vineyard, as well as canopy management, how those can change the metabolic pathways of flavor formation. And for example, here we know that some of the very important flavor compounds we call the beta-dimethanol, and this is the compounds, and they do a lot of trick in the wine to the wine quality. So we put a lot of research focused on these compounds, and we'll see from the precursor side what we can do in the vineyard. They can either increase the formation of precursors, as well as they can increase the formation of these key and flavor compounds. So that is a kind of approach. We did a lot in the past 20 years. We have a wide range of collaboration, and here in Oregon, as well as research scientists in Australia, because they also deal with Pinot Noir and research, and we understand the viticultural practice on the flavor precursor formation in the grapes, such as how we are with basal leaf removal, how we control the irrigation, how the cyanide will affect it. So once we have this grape quality, we also look at how in the wine making process, and for example, with the fermentation temperature and the different yeast, how those will affect the conversion from the precursor to the wine flavor compounds, and finally to the wine quality. So out of all of this study, we also look at the aging, and for example, with different wine closure, how the oxygen permeability affected the flavor. So the different project. Current project we have been studying this area, is look at optimum irrigation and continuously working in this area. We are looking at agriculture, the sustainable agriculture, and use minimum amount of water. And in our agricultural practice, how we can use least amount at the same time, maintain the wine and grape quality, or even improve and the flavor quality. And this is a current research project and supported by USDA and Small Fruit Research. We have collaborators here and in the Southern Oregon, because that is more in the dry and area. Of course, Oregon, unfortunately, with the climate change, and more recently, we got an issue with wildfire. With wildfire, they can create smoke, and those smoke can impact the quality of like the grapes, like other agricultural products. So in our lab, we do the smoke analysis. We try to develop a fast analytical protocol so we can evaluate and we can assess smoke exposure as well as grape and quality. There's other things we have been working on. This is another project that we worked a little while. Is we're looking at flavor modulation, and this is particularly looking at polysaccharide, how the wine polysaccharide can interact with different flavor compounds, so they can create or modulate the wine mouthfeel. So there's all different kind of a project that's going on. Other miscellaneous project, we're working in the lab. I just mentioned that we do work on the coffee. Now we're working on espresso coffee, look at this quality, and the seafood, and the different alcoholic beverages, distilled spirit, and tequila, and baijiu, as well as we, different, and sometimes we deal with whiskey type of products. So it's a different sense. Is working on in the lab. Well, in addition to the flavor side of a project, we look at other things and look at the volatile compounds. That is a different story. Is look at the volatile compounds, how we can use the volatile compounds to with pest, with disease control. And this is a collaboration with many different universities, and again address agriculture sustainability with less and or no chemical application to control the disease. The background for this is we have a garlic white rot disease, and this is and this kind of a disease they affect the garlic and create the white rot. And the issue is this: they create a sclerotia. If the sclerotia is without host plant, they can stay in the soil more than 40 years or so. But once we plant the garlic, those sclerotia become germinated, they will attack the garlic plants. As a result, create issue with loss. Traditionally, they use a chemical for the control, but all those chemicals, many of those chemical treatment is very bad for environment. So we want to remove that, and we try to use is looking at the natural compounds in the garlic and whereas other natural resources. So without we can activate those dominant sclerotia and without toxic chemicals. So preserve the soil, the farmland. Specifically, we are looking for volatile styles, so the sulfur compounds, so they can activate those sclerotia. So we are using identify different bioactive organic sulfur compounds, and particularly in onion, in the garlic, and then looking for those, and we can provide a biostimulant. So we can germinate the sclerotia without the garlic. So we are that way we can control and then reduce the sclerotia in the soil. So to take a sustainable approach. So that's a different project. I'll give you an example. What kind of project we're working on. And very quickly, I wanted to cover second part is looking at technical capabilities in the flavor chemistry lab. So what kind of instrumentation we are using. We are heavily for the volatile analysis. Now we are heavily use the GC mass spec, and the instrument we equipped with different water samples so we can analyze volatile compounds at the parts per billion level from food or different matrix. And this is the instrument we are heavily use with the GC mass spec, with headspace, automatically solid phase micro extraction and the capabilities, so we can extract. And another technique we heavily use, we call something called a stir-bar soft-tip extraction and a GC mass spec. Again, this is a technique that will be able to extract the volatile compounds reliably. And this is the instrument that we have, the GC mass spec, and the instrument in the lab. We can do this stir-bar soft-tip extraction. The sample and this kind of a technique make a flavor analysis is easier, is more reproducible. And for example, and we if we study the flavor in fruits, in the juice, we can take the juice, put the stir-bar, stir it, and then the volatile compound will get extracted. We can run the GC mass spec and do the flavor analysis. So very, very handy. The lab is also, we have a different specific GC detector, so we can screen and specific flavor compounds, such as for compound, such as detector specifically for nitrogen compounds, which is very useful for coffee flavor. For example, the coffee pyrazine, a lot of pyrazine type of compounds. So it's very specific. We also have been working on the sulfur compounds. This is a pulsed flame photometric detector. For sulfur compound detection, we have the instrument is here. We heavily use and looking at the volatile sulfur compounds because the volatile small, very tiny amount of volatile sulfur compounds and contribute significantly or contribute a lot to the flavor. So example, we look at the different aging of cheese. In the cheddar cheese, we look at the different sulfur compounds. As you can see, as the cheese aging, as we expected, we can see different sulfur compounds will increase. We look at the sulfur compounds.
1 minute warning.
Oh, okay. We get sulfur compounds in the wine. We also have a 2D dimensional GC. We can use a hard cut and looking for different chiral isomer. So we are using 2-dimensional GC, use a hard cut, and then we'll be able to see different chiral structure, looking for stability. Different fruits. And finally, we use this is a multi-comprehensive GC tofu mass spec we use for the separation. Final words. I'm also happy to involved with American Chemical Society. We have international flavor conferences in South America and Asia. So the first in Colombia, second in China in Wuxi, the third one is in Chile. The fourth one will be in Asia again. Thank you for your time. Thank you for attention.
Thank you very much for that very informative, excellent presentation. At this point, any questions from the group, from the audience? Either online or at IPB?
Okay, thank you. It's very nice presentation, Professor Michael. It's very nice presentation, Professor Michael.
Thank you.
I'd like to know about the study on flavor precursors for flavor aroma compounds. You studied about several precursors, for example, from carbohydrates, like mono or disaccharides. Did you do spiking for the verification to the to prove the flavor precursors? Did you do the spiking of monosaccharides or disaccharides to any sample to prove the formation of the flavored aroma? Thank you.
Okay. Let me put this. Let me try to understand your question and correctly. For all those aroma compounds, we always use the standard for identification to conform. So for all compounds that depends on if either it's in the fruit or in the wine, we have to use standard to verify both conform with mass spec and with retention. I know that has been an issue, so we do that. We have 1,000 compounds in the lab to verify. Does that answer your question?
Could you please repeat again the answer?
So we, yes, for all the flavor compounds, we have a standard. So we spike it in the sample to confirm the chemical structure and for the analysis.
To prove the precursor for the aroma, for example, precursor for linalool or any aroma compounds, you did standard spiking to yours, maybe plant or any botanical
I see.
to prove the aroma formation?
No. If we are looking for plant precursor, we did not spike to the plant itself. Yeah, we did not add sugar or nutrient and put another plant to synthesize the precursor. We did not do that part.
I think we're at the 7 o'clock mark.
Sorry, I think it's the connection.
We have a delay. Okay, Boeing, I'm going to turn it back over to you.
Sorry, the connection in our room is very bad. Do you hear my voice?
Yes.
Yes.
Okay, thank you. My question is about the precursor for the aroma formation. Did you do the spiking of, for example, saccharides, mono or disaccharides, to botanical or to plant to prove the formation of the aroma formation? Thank you very much.
Yes.
Sorry, I want to load my speaker.
Okay, no, we did not do
First,
that. Okay, we do not
Yeah.
do, we do not spike either the sugar or the nutrient into grapes to prove that a precursor.
sorry.
Boeing, are you hearing me okay?
Can you hear us, Dave?
Yeah, I can hear you.
I don't know if you hear us.
Yeah, Boeing, I can follow up with Dr. Chan's
Okay.
answer to that question if we want to go on to the next speaker.
Right, right. Okay, good. So I think Dr. Chen and Professor Hanifa, probably you can talk later because the next speaker will be Professor Hanifa. She is professor at the Department of Food Science and Technology. So hope both of you will be connected later on. Her interest areas are in the food chemistry, taste perception, and savory compounds. So Professor Hanifa, the time is yours, 15 minutes. Thank you.
Thank you very much. I share my slide. Thank you very much. I would like to present about my interest of research about taste chemistry. Taste chemistry of fermented soybean products. Here we have Indonesian soy sauce. We call it as ketchup. And then Japanese soy sauce called soyu. That's Japanese language, soyu. Then the other soybean products, Okinawan tofu, Okinawan fermented tofu, called as tofuyu. Tofuyu is an Okinawan language. Then Indonesian soybean paste, we call it tauco. It's also famous here in Bogor, tauco. But actually, tauco is the name of Indonesian fermented soybean paste used around Indonesia. This is the pictures. We know the all fermented soybean products mostly having umami taste or mostly having savory taste. The use of the fermented soybean products mostly as a seasoning or condiments, ketchup as condiment, sometimes a seasoning, tauco mostly as seasoning, shoyu mostly as seasoning, and then tofuyu. Tofuyu is condiment in Okinawa. Umami taste has been known as one of basic tastes. We know the taste in fermented soybean products. For example, ketchup, soyu, then miso in Japan, doenjang in Korea, mostly because of the amino acids and peptides. And we know many amino acids having taste. For example, glutamate and aspartate having umami taste, the other having sweet taste or bitter taste. Soybeans, special legume. Soybeans having quite high protein content, almost 40% or almost 45% in the other variety. The production of fermented soybean products in Asian countries mostly consists of two steps. First, solid state fermentation. The second step, semi-solid or liquid state fermentation. This is the production of Indonesian ketchup. Firstly, to obtain koji, and the second step to obtain moromi. In the final step, the moromi, cooked with palm sugar And then for the show you, so next slide. Stop share first because sometimes the next slide trouble. The production of shoyu, Japanese soy sauce, also the same. Firstly, to obtain koji, and the second to obtain moromi. The difference is the raw material composition. In Indonesia, Indonesian soy sauce using using soybeans and sodium chloride, but in Japan, using mixture of wheat and mixture of cereals, the koji from cereals, and the wheat from kind of cereal, koji from soybeans, and then sodium chloride. After having moromi, the moromi in Japan mostly just pasteurized and then marketed. The production of tofu also consists of two steps, but the fermentation is only in the second step. The first step, making tofu with very hard tofu, and then the second step is fermentation in the slurry. The slurry made from red rice and yellow rice and awamori mixed with awamori. Awamori is an ethanolic beverage of Okinawa, and then sodium chloride. But the concentration of sodium chloride is very low compared to soyu or compared to cheese. After 3 months, we can get the tofu. Then the production of taucho consists of two steps of fermentation. Firstly, to obtain koji, and the second to obtain moromi. But the moromi we can call it as taucho. If the taucho not heated, we can call it as raw taucho. But if heated by pasteurization or heated with boiling and adding palm sugar, we call it as taucho. Taucho like we can get it in the market in a bottle. So to track the umami compounds in the fermented soybean products, we should have the moromi or the raw taucho or the tofu yogurt without the slurry, and then we make it as a water-soluble extract, and then we separate the water-soluble extracts by ultrafiltration, and then followed by gel filtration chromatography, followed by HPLC preparative HPLC using C18 and using high-leak HPLC. Okay. We use stepwise ultrafiltration, and then gel filtration chromatography to obtain umami fraction. And then the umami fraction analyzed using HPLC to know the composition of amino acids, sometimes to know the composition of free amino acids and residual amino acids. This is the umami and salty taste intensity of ketchup fractions. We have fraction 2 and fraction 3 as umami fractions. We analyze using sensory panel, human sensory panel, with the original sample fraction and with the sample fraction, but added with salt to have the same salt concentrations. And in soyu also the same, to analyze the umami fraction, we separate the water-soluble extract, and then the umami fractions separated further using HPLC, and also the HPLC sometimes 2 steps using reverse phase C18 and then using high-leak HPLC. Then after we get the umami fraction, we analyze the amino acids composition in the fractions, and also sometimes we check the confirmation of the compound using LC-MS and using NMR, proton NMR. For the view also the same, we make separation for water-soluble extracts. And the umami fraction, for example, from HPLC preparative separation, we analyze by amino acid analyzer, or sometimes we confirm with the LC-MS NMR. From these experiments, we know one phenomenon. The phenomenon, the enhancement of MSG, monosodium glutamate or glutamic acid with sodium chloride, by bitter compounds, by in this case bitter amino acids, have been proven using standard chemicals and by sensory panel. We also studied 24 Tauco products in Indonesia. We analyzed the proximate composition and we can divide it, the 24 Tauco products into 3 groups: liquid Tauco, semi-solid Tauco, and solid Tauco. And if we compare the Tauco products with the other soybean paste in the other Asian countries, for example, in Korea, doenjang, from Japan, miso, from Thailand, tuanao. So the solid Tauco mimics miso in Japan. Liquid Tauco mimics dajang in Korea, or doenjang in Korea. While the semi-solid Tauco near to Thais. We also analyze this Tauco product for the next. I should stop share first. We also analyze the 24 Tauco products by Sensomics. And we found 17 umami peptides. The manuscript still under preparation, not yet submitted. 24 Tauco products with having umami taste. We analyze the free amino acids and the residual amino acids, and then we analyze the fractions with LC high resolution MS or LC-MS for peptidomics or for peptide identification. We have it in IPB University. And there are 17 umami peptides. We use Sensomic using statistic analysis by Simca software. 10 of 17 umami peptides having glutamic acid in the sequence. And 3 of them have been proven by molecular docking on T1R1, T1R3 receptor. Okay, thank you very much. This is the phenomenon found by our team. And then this is the research team from several universities. And this the instrument LC high resolution MS in IPB University. Me with blue color at the left side. Thank you very much.
Right, thank you very much, Dr. Hanifa, for your presentation. Is there any question coming from the floor, please? Okay, Bu Hanifa, I would like to ask one question. In your presentation, you mentioned that several amino acids may contribute to umami taste, right?
Yes.
And then this umami taste is enhanced by the bitter amino acids.
Bitter amino
right?
acids. Yeah.
And my question is there any interaction with especially these aromatic amino acids? Because I think that we can eat, let's say, peptides containing umami amino acids, but also having antioxidant activity. Thank you.
Yes, I think because I think so because currently in the last 5 years there are some journal papers reporting the umami peptides having antioxidant activities. Actually, that idea also might focus in the future.
All right, thank you very much, Dr. Hanifah. Any other question probably from OSU side? No? Okay, great. Once again, thank you very much, Dr. Hanifah. I would like to give the opportunity back to Dave. Please, Dave.
Thank you, Boeing. Dr. Hanifa, that was really interesting. I just want to make a comment that a lot of our chefs in the US are using these products like koji and many other pastes in new ways that I haven't seen in American fusion cuisine. So it's really exciting to hear the research you're doing. Dr. Chan, I would like to point out that there's a question for you in the chat if you want to address that through the chat regarding your research as well. Okay, so the next presentation, I have the, again, honor of introducing Dr. Jung Kwon, the assistant professor in the Department of Food Science and Technology here at OSU. Dr. Kwon is part of the Nutritional Pharmacology Lab, where she studies the biological effects and functions of natural molecules derived from diverse marine species at both the cellular and physiological levels. So with that, I turn it over to you, Dr. Kwon. Thank you.
Hello, and thank you. Thank you for the introduction and for organizing this exciting meeting. I'm very excited to meet with colleagues at IPB and really looking forward to some potential opportunity for collaboration. Let me share my screen. Hopefully I'll share it correctly. Are you seeing the presentation mode?
Looks great. Yeah.
Great. Yeah. So again, my name is Jung Kwon. I am an assistant professor at the Department of Food Science and Technology at OSU, and I run the research program of nutritional pharmacology, as Dave explained. And so today I just like to briefly share my research program, and I wanted to share some of the key snapshot of the several research projects that's currently ongoing in a hope that to identify some mutual research interest with colleagues at IPB. So some of general backgrounds of my research. So the linkage between food and disease prevention is not something new, or it's a very familiar concept to most people here, I'm sure, and it's a well accepted notion. So I won't be going into too much detail, but my research is based on this concept that food and dietary components can elicit functional and beneficial effects, sometimes therapeutical effects to human health, on top of their traditional basic nutritional contents and nutritional values. And so my research aims to identify such novel functions of food and dietary constituents or certain natural products. And in conjunction to that aspect, sustainability and better utilization of novel natural resources is another aspect that my research has been really focusing on. This is related to modern food processing. Industrial food processing really tends to discards a large portion of the raw materials and harvested resources as byproducts or waste product, which is not an optimal way of utilizing those harvest resources. And those byproducts tend to be not consumed by humans typically, So as an example, in the fish processing and industrial fish processing, anywhere between 30 to 70% of the raw material is discarded as a byproduct or waste material. So my research wants to focus on this fact, and that these byproducts a lot of times have really good nutritional value. It's a highly nutritional material, and then they even have a potential to be developed and utilized as an application for certain application for human health. So these are what my research is trying to combine and then develop into a program where the goal of the research is to uncover the beneficial effect of natural resources. In particular, I am focusing on marine-derived materials. So their effects on health promotion and disease prevention, while really focusing on underutilized resources and aim to improve their utilization and their value that hasn't been identified. So the interest is a wide ranging. So in my research, as I will go over in a minute, we focus on several different natural products, such as macroalgae, the seaweed, and fish and shellfish derived protein and peptide products, as well as byproduct stream. And we utilize whole food as a research material, and also bioactive compounds that's derived from food products. And we are interested in their potential benefits toward the metabolic health, anti-obesity activity, metabolic regulation, and some other interests also includes aging-related chronic diseases such as muscle health and skin health. So I will introduce a few of the key research projects that lies under this overall research interest. So first research is about seaweed project. So we are looking at the seaweed, potential effect of seaweed for metabolic health improvement under Western diet. So just to share a brief background, so unlike Indonesia, which I think seaweed is one of the, Indonesia is one of the largest seaweed producer, actually. The US is really at the beginning stage of producing producing seaweed and also putting it to the market. So we are really taking the beginning step of that. And also seaweed is really a new commodity for majority of the consumers in the US. And we know that seaweed is very healthy and inherently very healthy product with a really rich nutritional value. And also its nutraceutical value and other health benefits has been well reported. But since it hasn't been a really traditional part of the American diet, traditional American diet, it's very intriguing to ask the question if including the seaweed in American dinner plate, would it be supportive measure for this crisis of metabolic diseases that's US is currently undergoing. As you may familiar, the obesity rate and metabolic disease in the US is very prevalent, and it's an increasingly concerning medical issue. So in this study, we conducted a dietary feeding study of whole seaweed of the Pacific dulse. It's local seaweed that's produced here in Pacific Northwest. provided this as a dietary supplementation for the mice study that's under fed Western style diet to see if it can provide metabolic benefits. So just to provide a quick findings that we found from this study, it was 12-week study, 12 weeks feeding study, utilizing mouse model of C57BL6J mice. So we found a pretty promising result from this trial. We compared regular control diet fed mice and high-fat diet fed mice and high-fat diet supplemented with this specific dose. And the weight gain that's exhibited by the high-fat diet, of course, has been suppressed with Pacific dose, and it also will support the improvement of glucose metabolism by suppressing by accelerating the glucose clearance and insulin response, and it was able to suppress several inflammatory cytokines that increased by high-fat diet. This is MCP1 among other cytokines, and also furthermore, improved the overall liver health. We were able to see the reduction of the fatty liver condition of this specific dose supplemented mice groups. So overall, very, very exciting finding, and our follow-up study on this is currently undergoing to look at some of the detailed mechanism supporting this, the metabolic benefits. And because of we've been seeing positive outcome from the seaweed trial, we had some other direction of the seaweed project, which was looking at its protein and bioactive peptide discovery. So we focused on the fact that the Pacific dulse, similar to many other seaweed, has a pretty high protein content. About 20% of dry weight is protein. So we wanted to take this direction of looking at potential bioactivity of this protein and this peptides. For this study, we adopted two different approaches, including in silico and in vitro testing of bioactivity of these peptides. Just in case if you're not familiar with in silico approach, is solely based on computer simulation. So unlike the conventional lab bench-based study, in silico utilizes web database that's available, and we rely on using this web-based tools to conduct any kind of enzyme hydrolysis and predicting the bioactivities of generated peptides. And then we also compare this to traditional in vitro study. So just to show the quick overview, we generated a large amount of in silico based data, just utilizing several different platforms of bioactivity prediction, and we narrowed down a few of our key peptides, potential key peptides, and we sensitized those peptides and then tested its bioactivity in vitro. This is testing of anti-inflammatory activity of those peptides, and several of those our predicted peptides indeed elicited some of the promising anti-inflammatory activities, as we've seen. This is result based on the macrophage inflammatory response. Another project that I just want to briefly go over, next couple of projects I'll talk about is we are interested in some of the aging-related health conditions as well. So in this project, we are looking at potential beneficial activities of fish byproduct derived protein product for muscle health support. So in this specific project, we are looking at muscle myotube formation. So it's a C2C12 myoblast cell line that we can culture and then differentiate and to let it form myotube, which is a building block of the muscle fibers. And Alaska pollock is a highly abundant fish species in this Alaska region, and its milt is a byproduct that does not have a lot of value here locally. So we utilize that to see the potential benefits on the muscle support. And we are seeing some promising results when the muscle myotube formation is suppressed by the dexamethasone, the glucocorticoid compound, but when the milt hydrolysate was able to recover is the muscle diameter myotube formation in these cells. And then we are checking some of the gene expression associated with muscle protein synthesis and muscle protein degradation. And we found several genes that's related to muscle protein degradation has been suppressed by the milt hydrolysates. And on the other hand, muscle protein synthesis related genes such as myogenin and S6 kinase has been recovered by this milt hydrolysate. So that project is also actively ongoing. Just quickly, finally, this is another project that we utilized fish byproduct peptide, looking at its potential impact on skin health. So skin health is another aging-related concern when your skin is exposed to excessive UVB radiation. It can generate a lot of adverse effect on skin health, particularly it's called skin photoaging, and can cause premature aging of the skin and wrinkling, basically, of the skin. And we focus on the fact Pacific fish skin is really high in collagen, and it is reported to have skin protective effects. And Pacific whiting is also a local fish species, and then its skin is not highly accepted product by consumers. So we conducted this project where we look at the effect of Pacific whiting skin hydrolysates on the UVB-induced skin photoaging utilizing human dermal fibroblast cells. And in this project, we saw positive findings where the type 1 pro-collagen in this dermal fibroblast, which was suppressed by the UVB induction, it was able to recover to a certain level by the Pacific whiting skin hydrolysate compound. And this is coincided by the MMP1, which is enzyme that's related to degradation of this skin collagen. So we were able to look at the suppressive effect of this protein hydrolysate on MMP1 enzyme, and we saw some of the supportive evidence as well in the molecular mechanism pathway, including the MAP kinase and NF-kappa B pathways. So just to wrap up some of the project that I went over, the research is really aiming to have this impact of functional food and therapeutic application development to finally improve human health. And also it's focusing on facilitating optimal resource utilization, which will then support sustainable practices. So it's a wide range of interests, and which I hope we'll be able to find some collaborative opportunities. Some of the key concepts for the interest include natural resource utilization and bioactive compound discovery, and different biological model studies, and key interests are metabolic health improvement and diet and aging associated chronic diseases. So hopefully there will be a mutual interest, and I really hope to develop any potential collaboration. So that was a really quick overview. Thank you, and do we have time for questions?
Yeah, Dr. Kwan, thank you very much. I always learn so much listening to you talk. Any questions from the audience?
Dr. Dev, I have a questions to
Please.
Dr. Kwan. Okay. Thank you, Dr. Kwan, for such a nice and comprehensive presentation. I would like to ask about your first research example when you use obese mouse model, if I'm not mistaken. So you use the whole plants, or you just did fractionation to feed to your mouse?
Sorry, I missed the last part of the question. So when we use the obese mice, what was the question after that?
Did you use the whole plants? The whole seaweed, sorry.
Oh, yes. So in that study, we utilized the whole seaweed as a to supplement the diet that we are giving to the mice. Yeah, so the idea was if we provide this seaweed as a whole to American consumers, would it have a beneficial effect when they are on their Western style high-fat diet? So for that reason, we conducted a whole seaweed supplementation study.
So you didn't want to identify which compounds present in the seaweed responsible for the anti-obese activity?
Yeah, so that's an intriguing question. And yeah, we are interested in conducting following up study. So doing that seaweed protein study, seaweed protein and peptide was one of the directions that we pursued. But we are also interested in looking at potential prebiotic effects, because I didn't share in the results, but we also did some gut microbiome analysis from that in vivo trial, and we saw some changes of the gut microbiome. So potentially provide prebiotic effects, or based on polysaccharides components is another direction that we are interested in. Yeah, thank you for that question.
Thank you very much for your answer. Thank you.
Thank you very much, Professor Kwan. Actually, I have an interest on the seaweed research. Currently, we have publication on, sorry, that one not seaweed. Currently, we are doing research on Gracilaria. Do you know Gracilaria? That one also seaweed in our country, for finding umami peptides from the Gracilaria. And the other study already done from microalga, spirulina, a source of umami peptides.
Mm-hmm.
Yeah, already published in ALGA research.
Mm-hmm. Yeah, that's really great. Yeah, I'm really interested in being connected with anyone who loves seaweed and really doing seaweed research.
Okay, thank you.
Thank you.
Okay, thank you, Dr. Kwan. With that, I'll turn it back over to you, Boeing.
Right. Thank you very much, Dave. Thank you, Dr. Kwon, for your very nice and interesting presentation regarding these peptides coming from marine resources. Okay, we're going to move on to the next speaker will be Associate Professor Nancy D. Juliana. Dr. Nancy is a lecturer at the Department of Food Science and Technology. She would like to talk about plant metabolomics and natural product chemistry. So please, Dr. Nancy.
Thank you, Dr. Aziz, and thank you, Dr. Dev, for this great opportunity. Can you hear my? Oh, okay. Is it okay now? Thank you. Okay, so I would like to share my screen. Can you see it? Yes? Okay, thank you. So the topic of my presentation is the research on Indonesian plant food using metabolomics approach. This is the outline of my presentation. So first I will start with some introduction. After that I will give an overview about the research I conducted in our university. And after that I would like to give example of our collaborative research and our ongoing research. So I don't know, maybe in the US it's the same, yeah, but in Indonesia we are granted with strategic geographic position. So for that, Indonesia is known as the second largest biodiversity in the world. We have 40,000 plant species, more or less. 6,000 are medicinal plants, and I don't know the exact data, but I think some of them are edible plants. So it is always nice to focus on this topic of research to explore this Indonesian biodiversity. To find active biocompounds, because it is known that compounds derived from natural resource, they have more diverse and more unique chemical structure. Therefore, they also have more diverse biological functionality. So that's why they are very potential to be used as functional food or food ingredients. However, these natural products also have some limitation, because they are naturally present as a complex mixture of many different compounds with different psychochemical characteristics. So if we want to study these active compounds, we want to isolate them, we want to identify them, it is quite difficult. So here we prefer to use metabolomics approach, because when we use this method, it is like we are like this guy, so we just like standing up there to observe comprehensive or dynamic situation of a lot of compounds as the effect of different type of factor like varieties, origin, post-harvest handling or processing, how they can affect the chemical composition of these plants, also to detect adulteration, etc. Also, this is very helpful approach when we want to identify the active compounds from these plants, or if you want to study the compound toxicity or the proof of efficacy of the compound. Also, if we are interested to study the mode of action of these identified active compounds. So this is the workflow chart that we are used to work with when we use this metabolomic approach to study a lot of Indonesian plants. So we have our samples here, we get the treatments, like for example, we have some plants from different growing area, we have plants from different varieties or plant with different processing treatment. And after that, we can do to the right side or the left side, or we can do both. If we only want to study about the effect of, for example, different processing to the chemical profile of our samples, then we only go to the website here to conduct chemical profile analysis of our samples, and after that we analyze them. We analyze the data with multivariate data analysis, and then we can see the classification pattern and find out the compound responsible for the classification. Or if we want to correlate the chemical profile with a specific bioassay, either it's a health-related bioassay or it can also like a sensory evaluation of our sample, then we can use the same sample that we use already for chemical profile analysis for this bioassay or sensory evaluation. And after that, we correlate these two data again by using multivariate data analysis. So then in the end, we can identify compounds associated with the bioactivity or a specific sensory profile of the samples. So this is a typical research that I did in our university. Usually, I start with the screening of some potential foods for specific bioactivities, and after that, I will choose one of them with the most potential one, and we pick it for the bioactive compound identification study using metabolomics or volatilomics approach. And usually in the end, we confirm the activity found by this omic approach by using in silico and molecular docking. Also, sometimes we go to the number 2, sorry, I jump to number 3 directly, to investigate the effect of different factors to the concentration or the composition of the chemical compound present in our samples. So this is the first example of our past research. We did anti-diabetic and antioxidant screening with several Indonesian local vegetables. So these are very common vegetables that we can easily find in the market. So first we screened around, I think more than 20, but I don't know if I saw all the data, but we screened more than 20 local vegetables for anti-diabetes and antioxidant activities, and then we choose the most active one. In the study, we choose daun salam or salam leaves. Yeah, the Latin name is Eugenia polyanthum. This is a very common herb. I can say it's herb, not spices, not really vegetables. Common in Indonesia to be used as a condiment in many Indonesian dishes. So we choose that plant, and then we continue to identify the active compound associated with anti-diabetic and antioxidant activity by using NMR-based metabolomics. So this is just the analysis of the data using OPLS, multivariate data analysis. By means of 2D NMR and also LCMS, we identify that minocytline and epigallocatechin gallate is the two active compounds responsible for alpha-glucosidase inhibitor activity of the salam leaves. We confirm this finding by using in silico approach with acarbose as a native ligand, and we discovered that these two identified compounds had the most negative energy binding compared to other compounds. So we confirmed the result of our omic studies. We also conducted almost similar research, but we use underutilized species, Indonesian underutilized species from Zingiberase family. At this time, we use SPMA and GCMS and also multivariate data analysis. And with similar approach, we identify some volatiles which associated with the antioxidant and anti-diabetic activity of the spices, and we confirm again this finding by using in silico approach. This is the last example of our studies. I think this was done in 2018, quite a long time ago. So in this research, we use Melaleuca cajuputih as the source of cajuput essential oil. Cajuput essential oil is the important materials for cajuput candy. This was formulated by one of our professors in food chemistry division in our university. So the main source of this cajuput essential oil is in Buru Island. It is here, quite far away. But actually, cajuput plantation can also be found in other areas besides Pulau Buru. But we are afraid that if we use cajuput oil from other area, we are afraid that if the sensory profile is different. So we would like to identify which kajiput oil from these 12 areas in Indonesia is similar to the Buru Island, to the kajiput essential oil from Buru Island. We analyzed these 13 essential oil from different areas, including the one from Pulau Buru. We used it as a reference. We used GCMS and we analyzed by using PCA that we discovered that kajiput essential oil from Bupolo and Mojokerto are the closest one to the kajiput essential oil of Pulau Buru based on the tactile profile. And then we confirm this result by using organoleptic study. We use a panelist and we confirm this result from a metabolic study that indeed Bupolo and Mojokerto essential oil from these two areas had the closest sensory profile compared to the reference essential oil from Pulau Buru. And we also use the same approach to identify which compound associated with the negative and positive sensory attributes. I give here one example. Compounds associated with the cooling aftertaste as one of the positive compounds, positive sensory attributes. We use similar approach and we use OPLS to analyze the result and discover that terpinane and cineol are two compounds associated with higher cooling score from the organoleptic studies. We also had a collaboration with Japanese side in the past, and that collaboration resulted in the granted Japanese patent. So we developed a comprehensive extraction method coupled to multivariate analysis to identify fluorescent spectroscopic vegetative area related to the immunomodulator activity of plants, the common plant that we work with. So for the collaborative, for the future collaboration, I do wish that we can have some collaboration, especially using a common plant food, because otherwise we need to make like a material transfer agreement. We would like to, I'm quite interested with the research of Professor Michael Kian, and also Professor Jung Kwon, because I think we have the same interest. And currently, I have 3 PhD students, but they are still in the first year and still studying to find the topic research. So maybe I hope that one of them can involve in our collaborative research in the future. Also, we have now ongoing research. It was just announced last night, from Dr. Adis. Now, I have a research on metabolomics of Indonesian edible mushroom, and I'm interested to identify the bioactive component from this edible mushroom. So thank you again for this opportunity. I give the time back to Dr. Adis.
Right, thank you very much, Dr. Nancy. That's really speedy presentation, but I know all the information already delivered very well. So is there any question coming from the floor, please? Question?
Yeah, I just want to say that I really appreciated the presentation. It's really powerful tool, use the metabolomics to conduct those research. So you tested several bioactivities of those natural products that you've been testing, and what are the model systems that you used to test those bioactivities? I was just curious.
Thank you for the question, Dr. Kwan. So I forgot to explain, but I use in vitro study for the alpha-glucosidase inhibitor and antioxidant activity.
So were there cell-based studies, or was it just enzyme and just enzyme-based testing?
Yes, cell-based study. So we did use it with our collaborative research with the Japanese side, but the study that we did in IPB University, mostly we use in vitro because of the facility, I have to say.
Yeah, thank you. Yeah, I can definitely see lots of potential for collaboration, and I love to stay connected and have more conversation. Yeah, thank you.
Thank you very much.
Right. Is there any other question? Okay, I actually have one quick question to Dr. Nancy. In your study, especially in Chajubut candy, you found out that the cooling effect mainly provided by terpene and cineol, right? Are there any other functions, I mean biological functions, other than cooling effect for these two compounds?
Yeah, I think there are some research about it, and also in our recent research, we also detect that these two compounds associate as well with the antioxidant and antidiabetic activity. But it is in vitro studies, so I think we need to confirm this using in vivo. It is interesting to use the same mouse model with the Dr. Kwan used in her research.
Right, thank you. Thank you very much, Dr. Nancy, for your answer. Okay, one quick question probably from the floor. We still have 2 minutes left. Okay, I think we can wrap it up. Once again, thank you very much, Dr. Nancy. I would like to give the opportunity back to Dave. Please, Dave.
Thank you, Boeing. Yeah, Dr. Nancy, that was really interesting. Thank you for that talk. The next presenter from Oregon State University is Dr. Ford Evans. Dr. Evans is part of our Coastal Oregon Marine Experiment Station in Newport, where he works on a lot of different projects with different researchers related to aquaculture of shellfish and seaweed in the Pacific Northwest. So with that, I will turn it over to Ford.
All right, thank you, Dave. All right. Thank you very much. This is a fantastic opportunity to share with all of you the aquaculture research that's going on at the Hatfield Marine Science Center. Let me do that. Okay, my name is Ford Evans. I'm a research associate based out of the Hatfield Marine Science Center. I'm with the Coastal Oregon Marine Experiment Station in Newport, Oregon. And just to put a little context here, Newport, Oregon is about 2/3 or so up the Oregon coast here. This is Washington above us and California below. Here's the state of Oregon. And for perspective, here is the Hatfield Marine Science Center. It's actually a very large facility that includes multiple state and federal agencies. And importantly, this is the Pacific Ocean right here, and we're at the mouth of the Aquinnah River. We have the capacity to pump seawater, high quality seawater, about 600 gallons per minute. Typically, if it's pumped at high tide, we get very high water quality, ambient, cool, cold seawater temperatures and so forth. So a fantastic place to conduct research. What a presentation outline here, what I want to talk about is a pretty broad overview of some of the work that we're doing in the aquaculture lab at Hatfield Marine Science Center. The director, Chris Langdon, heads up that lab. And I want to cover basically a common theme here is that we do work with low trophic aquaculture species. And I want to focus first on some work that we've been doing with Pacific oysters for many years. Turn attention after that to also some work that we've been doing with seaweed, Pacific dulse. This is the same thing as the Devillaria mollusk that Dr. Kwan was talking about. This I've named it Palmaria mollusk. They're synonymous. And also finally wrap it up with some more recent work that we're beginning to do with purple sea urchins. So these are the three species I'm going to talk about, and pretty vague and probably too quickly, but here we go. All right, so shellfish aquaculture research at Hatfield Marine Science Center, is what we're really talking about here is the molluscan broodstock program. This is the primary shellfish research program that's going on out at the coast. And this is a selective breeding program that was started in 1996. Pacific oysters, Chrysostria gigas, are raised all over the world. They're economically important all over the world, and also particularly important on the west coast of the United States. They're one of the most important cultured marine species. Currently, well over $80 million estimated value in US dollars per year. And when we started the program in 1996, there were really no other established Pacific oyster breeding programs. The strategy that was used and has been used for many years is family-based selective breeding. And this is phenotypic selection, targeting improved oyster growth and survival. So essentially what we're talking about is improved oyster yield here. And by having family-based selection and a formal breeding program, of course, we can reduce rates of inbreeding and try to maintain genetic diversity. Throughout this program, we have focused on a transfer of improved broodstock to industry. That has been an integral part of the program from the beginning. As I mentioned, this program started in 1996. Founder populations came from the state of Washington, where there are some naturalized populations of Pacific oysters that are native to Asia, not to America. However, they don't reproduce. The water is too cold here, except in a couple locations where they have naturalized. From there, this broad genetic base, we used a selection program, a rotational breeding program to cross amongst these lines. Later on, this covers the first, 20 years or so here. I'm sorry, 10 years here. After that, we began to move into more directed crosses based on pedigree analysis, where we can be more selective on which parents come from which cohorts and so forth. Finally, we end up, in addition to phenotypic selection, also applying some marker-assisted selection towards the very end. I'm going to talk a little bit about that on the next slide. The program initiated, it was a USDA funded project, but run through Oregon State University. And more recently, it's now becoming a more formal USDA project through the Pacific Shellfish Research Unit that's located out at Hatfield Marine Science Center. These pictures just highlight, over the years, this breeding program has used, with strong industry partnership, we have explored oyster performance in a variety of culture methods. This is bag on bottom here, bottom one showing off bottom culture on racks. We've done suspended culture, all sorts of the entire vast variety of culture methods that are used along the west coast of the US that have probably been included in this breeding program at some point. The focus initially was on growth and survival. More recently, however, there is increased interest in focusing our selection goal to achieve increased tolerance to an Austrian herpes virus, OSHV1. This is particularly in Tomales Bay, but I should say that this herpes virus is a global threat. There are different variants, just like COVID. There are different variants of this virus throughout the world, different microvariants. They vary in pathogenicity. And in Tomales Bay, this is probably an endemic virus that is there, and the shellfish farmers there have largely learned to manage around this virus, usually through things like selecting a proper plant date for the oyster seed. They also may select larger seed to plant out versus smaller seed. So they've worked on ways to live with this virus there, which occurs, there can be outbreaks that occur annually. But what we'd like to do with our breeding program is to add to their toolbox selectively bred lines of oysters that are tolerant to OSHV1. So we began using that as our selection goal over the last several years. And this is a publication that was put out by Konstantin Divilov, who's here at Hatfield Marine Science Center, doing just that, focusing on survival during OSHV1 mortality events. And what you can see is that if you plot mean survival estimated breeding value, this is essentially the genetic value of the cohorts. Over time, each successive cohort or generation, we see about a 10 percentage point increase in the estimated breeding value. And then this final year here in 2021, there was both the phenotypic family-based selection that was applied, but also within family selection that marker-assisted selection allowed us to do. So we're seeing continual gains, and we're optimistic about this. This breeding program is a very large program. We're happy that USDA is taking it on, and I think it'll have long, productive life, and I hope it will do some good in developing strains that are tolerant to OSHB1. Shifting gears slightly, talking about seaweed, Dr. Kwan mentioned Pacific dulse. This is a species that we have been growing for some time at the Hatfield Marine Science Center. It is native to the west coast of the United States, from Alaska down to San Luis Obispo, California. It was first brought to Hatfield Marine Science Center in the late 1980s for the purpose of land-based cultivation and to be used specifically as essentially a biofilter to treat effluent from land-based salmon farms. And it was evaluated against a panel of other seaweeds, and it came out on top in terms of ease of culture, as well as its ability to take up nutrients. And of course, subsequently, we found that it is highly nutritious. In fact, its close relative, Palmaria palmata, and the Atlantic species, has been consumed by humans for millennia, as have native populations here on the West Coast as well. So we know it's a human, it's nutritious for humans, and we're beginning to see a lot of evidence to that effect. What our research has helped do is to really scale up and commercialize land-based cultivation of Pacific dulse. Some of the early, some of the early farms that came out of our work actually was Big Island abalone on the island of Hawaii. They use farm-raised, land-based farms to cultivate dulse and other seaweed to feed abalone, which they export to Japan. And that's their marketable product. They're using the dulse in this case as fodder for the abalone. Other farms closer to home, we have Oregon Seaweed, which started a farm in Bandon. This is in Southern Oregon and expanded up to a spot up in slightly, Northern Oregon along the coast. This company is targeting dulse for human consumption. Actually, they just released their product in a local health food store up in Portland, so they're actually doing quite well. And the common thing that you see here is something called tumble culture, and that's where air is delivered to the bottom of these tanks, agitates the tanks, keeps the biomass in suspension. A variety of benefits are associated with this. Of course, it cycles the seaweed plants up through this photic zone near the surface, necessary for photosynthesis, of course. The heavy aeration can also introduce atmospheric CO2, so a carbon source for photosynthesis. Heavy agitation that's associated with tumble culture can also decrease the boundary layer thickness at the plant liquid interface, so you get a more efficient gas and nutrient exchange. And that agitation can also help dislodge or prevent the seeding, really, of epiphytes on the algae. So there are a lot of benefits associated with tumble culture. Unfortunately, it is also a cost to the farmer. So one thing we were looking at doing, sometimes a prohibitive cost, but one thing we wanted to do in one of our research interests is looking at alternate ways of growing dulse rather than tumble culture. And where we began looking and focusing some of our attention is on the idea of immobilizing dulse on mesh panels and using the panels as a structure to suspend the algal biomass in the water column so that you don't need to rely on aeration to do that work for you. So we looked at a couple different techniques. One is in a tank-based system. Other systems that we were exploring and are just now beginning to look at is this notion of aeroponics. This is taking a page from the terrestrial agriculture world. This is just a chamber where we're spraying seawater onto panels of Pacific dulse. And we did see some, of course, we're supplying light, with atmospheric CO2, of course, is readily available. And we did see some very good growth rates, but there's obviously a lot of optimization to do here. But it's an interesting idea to try to produce biomass with a minimal amount of seawater, which if you wanted to move seaweed aquaculture inland, where acquiring seawater is difficult or maybe even impossible, you want to be able to grow these grow the algae with the smallest amount of seawater possible, whether it's trucked in seawater or artificially created seawater. Both costs are associated, of course, with both of those. The idea of using panels is particularly useful where tumboculture is not practical or possible. One place where it's not possible is in an offshore environment where you actually do have to contain the dulse on something. And in this case, we took our panels and deployed them in an offshore environment. This was actually a pretty neat trial that we did. We went straight out from the Science Center out into the Pacific Ocean where they have a channel marker here, hung some dulse panels off the side. The trial, I will say, was supposed to be 28 days. We went out after 14 days. I took these pictures. The dulse looked fantastic, no epiphytes, would appear to be very good growth. Right before we were going to harvest it on day 26 or 27, the Coast Guard told us that this buoy that our dulse was hanging from was missing from its location, and they presumed that it had sunk. So that was the end of that experiment. Something that I was not at all concerned about. I was worried about lots of other things, not having the buoy sink. But we're going to repeat this experiment this summer because I think it is an interesting way to at least demonstrate that the offshore environment is quite suitable for Pacific dulse. The last project I want to talk about is, again, using Pacific dulse, but here we're going back to using it as fodder for a high-value marine invertebrate, and that is the purple urchin. Purple urchin populations have exploded along the southern Oregon coast, and what appears at first to be a boon, it is a fisheries product. There's divers that go out and collect urchins for their uni. You'll probably, in the US anyways, you're most likely going to see it on sushi, but it's actually being prepared in many different ways. In a healthy reef, this is what your urchin, your harvested urchin is going to look like. But from an urchin barren, there's just not enough resource to devote to gonad production. You don't get the roe that is the marketable fraction, and you essentially have a marketless product. And that's what this cartoon here kind of describes. A lot of urchins, but unfortunately, they're all empty, devoid of any gonad material. You're not going to get any money for those. So the idea that we're looking at now is this idea of roe enhancement, where you take these, what people call zombie urchins, or completely empty urchins, feed them, bring them onto land-based tanks, feed them farm-raised dulse, and hopefully over some relatively short period of time, they develop large gonads, which then now these are marketable products and you can take them to market and sell them. That's the idea. So when we were testing this, we had a couple questions. One, will the urchins actually consume the dulse? And of course they did. They eat almost anything, but that's an important management number that you need to know. How much dulse are these animals going to eat in co-culture? The other question that I think most people were interested in is, will a monoalgal diet of Pacific dulse be nutritionally sufficient to increase gonad biomass? And the way we looked at that is using something called a gonad index, where we took the weight of the gonad. Essentially, what this tells you is what % of the live body weight can be attributed to gonadal tissue weight. And ranging from 0 to 5, you see very little gonad, 5 to 10% GI. It's getting there. And then this 15 to 20% is where we're beginning to get more into the marketable quality. 10 to 20% is about the range that people talk about as being a marketable product. So what we found last summer when we did some initial trials is that yes, indeed, their gonads will ripen up and relatively quickly, even when they're fed a dulse only diet. So these went from less than 2.5% gonad index up to 15 or approaching 15% gonad index over a relatively short period of time, about 10 to 12 weeks. So this is all very promising. We know that it's biologically feasible. The next thing we're going to start doing is taking a look at bioeconomic models to do a few things. One is to optimize production in terms of balancing dulse productivity. The more dulse you can produce, the more urchins you can fatten, and essentially the more money that you can make, the more product you have to sell. Another thing is dulse is not only a food source, but it's also a biofilter, an in situ biofilter. So you can take the effluent, the waste from the urchin tanks, recycle it back to the dulse tank, and then that nitrogenous waste can be used to essentially fertilize the dulse, increasing dulse production, which then gets fed to the urchins. And ideally, you have a win-win situation here. The biofiltration is also good for the effluent because now you're releasing water that has been at least, you could manage this to minimize the amount of nitrogen that exits the farm and is introduced into receiving waters. And hopefully you don't have issues of eutrophication and so forth. Of course, an economic model is also going to tell us if this is economically feasible. You have a lot of inputs, fertilizer. You need to actually collect these barren source purple urchins from a reef, and that is not necessarily going to be free. Seawater, certainly the power for seawater pumps, airlines, so forth. So we're now working on economic models to determine how much you're going to have to sell these urchins for to break even. And because some of these, or many of these values actually are experimentally derived either from our current experiment or past work that we've done with dulse, we do have variance terms that we can put around things like dulse growth rate, urchin gonad growth rate, urchin consumption of how much variation is there in terms of how much dulse urchins of a given size will consume and so forth. So these are all things that we can include into a model as well.
Board,
okay. Okay, well, that is all I have. So that was a brief overview of at least 3 of the projects that we have going on at the Hatfield Marine Science Center, all focusing on low trophic marine aquaculture species. Thank you very much.
Board, thank you. To the group at IPB, if you ever do, and I hope you do visit OSU, we'll be sure to bring you to Newport because the facilities and the research out there are world-class. Any questions for Ford?
Hello? Dr. Evans, can you hear my voice?
Yes.
Okay. Hi, Dr. Evans. I'm Julie. Thank you for the really nice presentation. And I have several questions actually, but I know the time is limited. My first question about the selection program that you did in Pacific Oyster. You saw that there's some increase in survival over generation. What I would like to ask is there any differences in growth? Because we have another example for shrimp, for instance, when they have a higher robustness against disease, the growth of the shrimp was lower. How about this in the case of Pacific oyster?
Yeah, that was our interest initially was in yield, which is a fairly crude way of measuring oyster production. But one reason why we did look at both survival and individual growth rate is to avoid the consequence of the invert for accidentally selecting for slow growth in the favor of high survival. Most recently, targeting the virus, OSHV1, there are no correlations with growth rate in that. So increasing tolerance to OSHV1 does not affect growth rate. Having said that, there is concern about rapid growth rate. Oysters die for different reasons, unfortunately. A fast-growing oyster could be putting so much energy. We see this with second-year summer mortality, animals that are near market size. If they are putting too much energy into growth, sometimes reproduction, they can be susceptible to sort of catastrophic summer mortality events. So it is something we're aware of and we try to avoid.
interesting. And my next question is there, I'm not too familiar with Palmaria, but is there any consideration why you do land-based seaweed culture instead of growing this seaweed in a coastal area?
Yeah, part of the reason, there's a few reasons. Part of the reason in Oregon, there is very little protected seawater, bays that will have full strength seawater suitable for seaweed culture. That is one issue. Other places like Puget Sound up in the state of Washington have a tremendous amount of protected seawater. What they run into there is actually it's more of a political thing. Regulators and getting the permits to put farms in places like Puget Sound is very difficult. And for instance, they figured out how to grow nori decades ago up there and wanted to put a farm in, but from a political standpoint, the community wasn't ready for a seaweed farm up there. So that's a problem. But others and suitable species, I'll add one other thing. Palmaria is a fairly small species, actually not unlike Gracilaria and some of the other species that you grow on lines there. So in some cases on the East Coast, there's larger species that can really benefit from long line culture. Sugar kelp is something on the East Coast of the United States that is actually gaining a lot of interest in culturing that. That is very well suited to long line culture because it takes advantage of a tremendous amount of water depth as the giant phalli drop down into the water. Dulse, as a smaller species, that also makes it a bit more suitable for land-based culture.
Okay, thank you.
Okay, thank you very much, Ford. With that, Boeing, I'll turn it back over to you.
Right, thank you very much, Dave. So now we're going to continue to the next speaker, will be Dr. Julie Ekasari. She would like to talk about aquaculture as well. She is from Department of Aquaculture, IPB University. So Dr. Julie, time is yours.
Well, first of all, thank you very much for the opportunity. I've been listening to many interesting presentations since this morning. So now we are going to into the water. Share my presentation. Okay, so my name is Julia Kasari. I'm an associate professor at the Department of Aquaculture. So yeah, I would like to introduce about what kind of aquaculture activities in IPB University. So as an introduction, this is our department, Department of Aquaculture in the Fisheries and Marine Science, in the Faculty of Fisheries and Marine Science. Our vision as the department is to become an internationally acknowledged higher education institution that produce the highest quality graduates in the field of tropical aquaculture. So yeah, this is just some numbers, an introduction to our department. So we have been experiencing about 16 years in aquaculture education, research, and community services. We have 25 lecturer staffs, 5 division or research clusters. So every year we have about 100 graduate, about 25 master, and around 7 PhD students. And each year, most of the lecturer can, we are quite active in doing research. Our average international publication is about 4, maybe still lower than you guys in Oregon State University. So these are the facilities that we have in campus. We have some analytical laboratories, teaching laboratories, wet laboratories, and also field laboratories, as you can see in the pictures. And we also have a mini feed mill for nutritional research. Whereas for field research station, we have for freshwater species, we have in the campus, and also another part in West Java. And for marine research station, we have in Ancol, in Jakarta, and also in the south coast of West Java, in Pelabuhan Ratu. And for the research clusters in our department, we have genetics and reproduction of aquatic organisms, fish nutrition and feed processing technology, aquaculture management, health of aquatic organisms, and also aquaculture environment. These are the ongoing research for the cluster of genetics and reproduction. We have been developing technologies for induced maturation and spawning for sustainable seed supplies. We have been experiencing seed supply shortage, especially during some season, like in dry season. So that's why we try to develop this technology. And also they have been in this cluster, have been developing natural phytohormone or natural compound to induce fish maturation and also sex reversal. We also did some marker assisted selection for some species, commonly in aquaculture, like tilapia or African catfish, mostly on freshwater aquaculture species. And there are also some research about chromosome set manipulation and also genetics improvement of seaweeds, mainly with Cavaficus alvarezi, and also Gracilaria. And there are also some projects in native species domestication and cryopreservation. For a sustainable and environmental friendly intensive aquaculture system, we have been developing some aquaculture systems such as biofloc technology, integrated multi-trophic aquaculture system, and then phytoremediation, including aquaponic production, and also recirculating aquaculture system for mud crab culture. And there's also some studies going on socioeconomic analysis of aquaculture activities, and also in aquaculture industry or community. For a cluster of health of aquatic organisms, there are some research going in DNA and protein recombinant vaccines, especially targeting on some diseases in Aeromonas hydrophila and koi herpes virus in some freshwater fish species like tilapia and common carp, and also African catfish. And there's also another study about maternal immunity, which help us to understand how immunity can be inherited to the seeds, and this and how this can improve the seeds quality. And then we also develop some local-based phytopharmacy because we know that antibiotics is highly prohibited for aquaculture species. So that's why we try to develop a local-based phytopharmacy using like herbs or other plants. And then we also develop some probiotics, prebiotics, symbiotics, and other immunostimulants for shrimp disease prevention. And we also develop some. We also have some studies in disease pathogenesis and develop relevant diagnostic tools for early disease diagnosis. And for the last cluster is fish nutrition and feed processing technology. In this cluster, we are focusing on developing locally based feed raw materials and its pre-treatment technology. Especially, we know that this is mainly because we have the issue on fish meal and
fish oil usage, and we want to replace it with something that is local. And in this subject, we are focusing on how to use byproducts, and also to find how to improve the quality of this byproduct by developing the pre-treatment technology. And also, we have been studying the phyto additives for developing functional aquaculture feed, as well as doing some re-evaluation of nutritional requirement for some fish, because this is mostly because we observe that the variables in aquaculture system has been increasing, and we believe that we need some adjustment on the nutritional requirement in the feed as well as in the fish larvae. And we also did some research in live food and microalgae production. So yeah, this is the collaboration that we have so far. I will skip that. We also have a national collaboration, especially with the community services. We work a lot with other universities and also with government agencies. Yeah, for my research interests in particular, so I have been doing, my team and I have been doing some research in focusing on the nutrient waste utilization through microbial conversion pathway, especially biofloc technology. And in relation to that, we also developed some water-based feed raw materials like seaweed, microbes, and microalgae. And this is something that I have been doing for the last couple of years, is to understand about shrimp gut microbiome studies. So in doing these projects, we have a collaboration with private sectors and some universities. Yeah, so just a short overview on what we have been doing. So this is one example of our research in biofloc technology development. So one of the most commonly found problems in the application of biofloc technology is the increase of microbial biomass accumulation. So based on that background, we developed a system together with Örebro University and Swedish University of Agriculture to have another, to modify biofloc system by having bioflocs in another separate tanks. And we use this tank as a kind of biofilter so that the microbial biomass accumulation only centralized in this tank, and it would not affect the fish itself. And we have a good result from this project, where we can have tilapia production, higher tilapia production in biofloc system with this kind of system compared to the conventional biofloc system. And in addition to that research, because we can centralize the microbial biomass generated from the conversion of nutrient waste in biofloc system, we can collect the microbial biomass and use it as a feed raw material for another fish or for the fish itself. So in this experiment, for instance, we try to find how much biofloc meal that we can add to African catfish diet. And we found that we can add biofloc meal up to about 20%. And interestingly, it has also positive effects on the survival, on the robustness of the fish against disease. And this is our most recent research. This is looking at the microbiome, the water and shrimp microbiome relation between the suspended solids, including the microbial suspended in the water, and also the shrimp gut microbiome. And we observed that based on the study, the carbon source added for nitrogen removal in shrimp culture water correlates with the diversity and also the composition of the microbiome in the water and also in the shrimp gut. And yeah, I think that will be all. We are looking forward to collaborating with you guys in OSU. So thank you very much. So just reach me out if you have any question. Thank you.
Right. Thank you very much, Dr. Julie, for your kind presentation. Okay, very nice presentation indeed. So do we have any question coming from the floor? Probably from the OSU side, please.
Yeah, I can ask a general question. That was a fantastic presentation and very impressive work you guys are doing there. You mentioned aquaponics. Is aquaponics in Indonesia has it scaled commercially? Is it a commercially viable a method of fish and vegetable production?
Yeah, thank you for the question, Dr. Evans. Well, commercial production is still limited, I have to admit, and from the research point of view, we believe that there are still many things that needs to be solved. We have done some research and showing that there is like imbalance between the production. Usually, what we experience until today is if we have a good like vegetables production, then the fish cannot grow. So we need to find the balance. That's why we also still doing the research to find out about this, or the other way around. So yeah.
Okay, good. Do you have any further question, Dr. Evans? No? No. Okay, good. Any other question coming from the floor? Okay, great. I hope Dr. Evans and Dr. Julie can collaborate in the future. Probably can start to communicate each other. So thank you very much once again, Dr. Julie, for your presentation. And with that, I would like to give the opportunity back to Dave. Thank you.
All right, thank you, Boeing. I'd like to congratulate everyone on how much we're completely on time here. This is amazing for faculty. This is great. Congratulations. Okay, so the last OSU faculty I'd like to introduce, it's my pleasure to introduce Dr. Brian Endres. Dr. Endres is a associate professor in the Department of Animal and Rangeland Sciences. He's also part of a very important program we have at Eastern Oregon University with agriculture. Dr. Endres' research seeks to identify and understand factors that influence vegetative structure, composition, and dynamics, and how this information can help inform natural resource management. So with that, I'd like to turn it over to Brian, please.
Well, thank you very much, David, and thank you for the invitation. I'm really excited to listen and obviously share some of the work that we've been working on here. So I'm just going to share my screen real quick. All right, great. Yeah, so as David mentioned, my name is Brian Endres. I'm an associate professor in the Department of Animal and Rangeland Sciences. And most of my work right now is currently based at the Eastern Oregon Agricultural Research Center, which is a long way away from the Pacific Ocean, for better or worse. But most of our work focuses on the sustainable use of agricultural and natural resources here in the interior part of Oregon. Just to give you an idea of what we do at this station, we come at our research in an effort to try to develop and generate knowledge that can help us continue to utilize healthy and productive farmland as well as native forests and grasslands of the region. Our work really is geared at not only farmers and producers, but then also different people who value different landscape resources, whether those are state agencies, indigenous communities, and so on and so forth. So when we think about the research that we do here, it's kind of at the interface of these four kind of very broad areas: livestock production, making sure that our grazing systems are sustainable and economically profitable. We also deal, like I said, a lot with the use and management of native ecosystems. So for here, it's a lot of coniferous forests, which you don't really get in Indonesia, but then also grasslands. And then we also focus quite a bit on how to restore any areas that have been degraded. Now, I have a long history of doing work outside of this area of the world as well. In terms of my background, I was actually trained as a tropical ecologist. So I've spent a lot of time in South America, the Pacific Islands, and Southeast Asia working on similar issues that are probably a little bit more familiar to you all in Indonesia. So my background is primarily in vegetation ecology, population dynamics, and natural resource management. And the overall goal of my research is really to generate, apply, and share knowledge that can inform how we sustainably utilize our natural resources, with the goal of supporting healthy ecosystems and then healthy communities who rely on those ecosystems for their livelihoods, their economies, their cultural traditions, and things like that. So as David mentioned, really in terms of our research that we do here, we are trying to understand how different management activities might affect primarily natural ecosystems. And that could be, when we think about management activities, that could be timber harvest, non-timber forest product extraction, grazing, prescribed fire, ecological restoration, many different factors. And then disturbances can also be really varied. It could be wildfires, land degradation due to development, invasive species, things like that. And usually what we're looking at is trying to understand how those different factors might influence different ecosystem services. So that could be biodiversity, wildlife habitat, livestock production, non-timber forest products, things like that. And ultimately, our goal is to inform sustainable management and stewardship. So I just wanted to emphasize that in our program, we have experience kind of looking at this at many different ecosystems globally. And so even though maybe Eastern Oregon seems very far and different than Indonesia, a lot of the same ecological principles are at play. And as I said, my background has been predominantly in the tropics and dealing with these issues in tropical, both moist tropical forests as well as montane tropical dry forests. And that kind of gives us, I think, a pretty neat perspective on how we think about managing ecosystems and the type of research that we conduct. And I'm going to give you a couple examples of the research here in just a moment. But one of the other things that when we think about our research program, we often pair kind of manipulative experiments or greenhouse or lab-based experiments with more field-based large-scale research projects, as well as various modeling and spatial analysis approaches. And so we tailor our methods and our approach to the problem. So we just don't do one kind of study and just do it in different places. We really listen and try to identify what the issues are, and then we build our research approach around that. And I think one of the keys for our research program has been a real participatory research approach. So As a scientist, I just don't kind of decide what I think is really important and then tell all my stakeholders and partners that this is what we need to do. We spend a lot of time listening to, these could be government agencies, local communities, our indigenous partners, other researchers, and really trying to understand what the issues are, and then have that kind of lead not only what questions we ask, but then how we want to try to design the research. And that way the research tends to be pretty applied and hopefully really meaningful. So when we get our results, those can be fed right into and address people's problems or concerns. The other thing when we do our research that is pretty important is yes, publishing papers in academic journals is absolutely important, but we also want to make sure that the research we are focusing on outreach, capacity building, and other parts of the project, so that then they can be applied and are more relevant to everyday management. Okay, so I just want to give you a couple examples of some research projects we're working on right now. For example, one of the research areas that we focus a lot on here in this region is trying to understand how different disturbance events interface with wildlife, livestock, and vegetation. Wildlife, livestock production are very important for our region, and we conduct a whole series of kind of large-scale experiments, really trying to understand how different stocking densities of livestock or abundance of other herbivores like these elk in this picture, how they may influence through their grazing and behavior the trajectory of forest structure and composition, and what that might mean for timber resources or other resources. So in these cases, we partner with a lot of wildlife biologists. We have opportunities to put GPS collars on wildlife so we can track their movement and activities, and we can look at this over very large landscapes and then go on and inform and provide results, provide results to communities and resource managers. So those are the types of work that we are involved with. And again, we have the opportunity to publish many different papers, and this is kind of just the highlights of some of the most recent publications that we've put out. And again, the goal here is to provide information, in this case, primarily to federal and state agencies who manage our parks and our forests, on what the implications of certain amounts of livestock or elk on the landscape, what it might mean for different resources. And we collaborate closely with the agencies, and this information then helps them make management decisions. Another part of our research, just to give you another example, is looking at non-timber forest product harvest, which I know is quite common in throughout Southeast Asia, including Indonesia, and it's important throughout the world. Currently we are working on non-timber forest products that some of them are economically important, but others are culturally important. For example, we have here in our region, many indigenous communities who rely on many, they call them first foods, wild harvested or wild plant resources that are important for their cultural, for their cultural needs and survival. And this is an issue that has created a lot of concern because there's essentially no research on the natural history or ecology of these species or how they might respond to different management activities such as timber harvest or grazing. And in this case, we have partnered and listened to our indigenous partners and then worked with them to develop all kinds of research, not only to better understand the ecology of these species, but also their management. And we have developed sort of long-term monitoring protocols that are now being implemented throughout the region. Another quick example, I wanted to throw in a tropical example for you, and this is work that it's been in the Peruvian Amazon I've worked on for over 10 years, and that's with the economically important plant species, which is Myrcia flexuosa. It's a very tall 30-meter palm which is found throughout the Amazon basin. And there was another one of these issues where there was very much a concern about overharvesting and the unregulated chopping down, cutting of the female palms to get at the fruit up in the canopy. And so not only did we do research kind of on the management and kind of the status of the species, we were also able to map throughout a large area of the Amazon kind of centers of extraction of like where the aguaje is being cut, and then engaging and working with communities on agroforestry and some sustainable harvesting technologies so that communities could climb the trees instead of cutting them down. And so that was another example of kind of the type of work that we like to do in terms of addressing natural resource challenges. And again, we like to put out lots of peer-reviewed publications on this, but again, one of the things that I think I would like to emphasize is our importance on outreach and capacity building. And so that's spending time with people in the field, and it's not necessarily always on the projects that I've discussed. I also do quite a bit of work in the Republic of Palau, which is a little bit closer to Indonesia, not that far away, on other natural resource issues. And again, while my expertise is predominantly in vegetation dynamics and forest management, if our partners in country have other express needs, we really work hard to figure out how to assist or provide the capacity that they need, and so we can learn from them and they can learn from us, and we can generate some good reports. For example, just like this gender and natural resource report from Palau, we worked with the government and many communities to try to provide an overall snapshot of the status of their terrestrial resources. So I think with that, that's just kind of a very quick overview of kind of the different types of projects that we work on. I'm really excited. I haven't been able to listen to all the presentations, but it's been great to listen to all the work that you are all doing there, and look forward to potentially developing any collaborations or partnerships related to land management and sustainable natural resource management. So that's all I have, Dave. I finished early.
No, you're great. You're right on time, actually. Thank you so much, Brian.
Yep.
Any questions for Dr. Indris?
I have a question, Dr. Brian. We have quite a lot of problems. So
Sounds like the microphone might be giving some replay. Boeing, I don't think we can hear on our end what's being asked.
How about now?
Yeah, it sounds better.
Okay, good.
yeah, I think I will later on inform you about our situation, especially how to restore the dryland area due to open mine activities. Maybe you have experience how to restore the open pit area, open mining area. Basically, there are 100,000 of hectares of Indonesia nowadays open for nickel, actually, tin or other things. Basically, we have problem there. Of course, we have to wait it. So far, the government just use regular trees, actually. But we know that if we use regular homogeneous trees, then we will lose some economic and ecological services. Maybe you can share some experience related to that area. Thank you.
Yeah, that is a great question. And in fact, I'm working on a project in Palau right now with partners on old bauxite mines from the Japanese in World War II. And there's been no revegetation of those bauxite mines since World War II. And the U.S. Forest Service has tried many times to introduce non-native species to try to rehabilitate these abandoned mines. And turned out that with some partners, and most of the partners were doing most of them in country, started evaluating different mixes of soil amendments with native trees. And they've been wildly successful, so much so that the Forest Service is now funding these local communities based on this kind of local approach to recovering and rehabilitating the soil on those sites. So you know, there might be some connections there for sure, and it was I can say it's been very impressive to see these areas that I've seen for 30 years that have nothing growing on them in the last 2 or 3 years, kind of a trial and error of native species as reforestation or reclamation species to get on site. So there are ways to go about that. Certainly be really interested in exploring potential efforts related to mine reclamation. It's a big deal, and there's a lot of mines around.
Okay, thank you.
Great. I think we have time for another question for Brian. Okay, if not, then I turn it back over to you, Boeing.
Right. Thank you very much, Dave, and thank you very much, Dr. Brian, for your presentation. And now we're moving forward with the last presenter coming from IPB University, Dr. Baba Barus. He is an associate professor from the Department of Soil Science and Land Resources. He would like to talk about land degradation and soil erosion. So please, Dr. Baba Barus, the time is yours. Thank you.
Thank you, Dr. Aziz. Ladies and gentlemen, I'm going to share our experience, especially using remote sensing and actually geospatial for agriculture and soil research. There will be 6 points I will inform, starting from introduction and new research that we have conducted, as well as consultation services and new challenge from food estate in North Sumatra, and I will end with some proposal to collaboration. Yeah, actually from erosion perspective in Indonesia, yes, there are a lot of problem about erosion, but when we talk about erosion, basically people not really concerned about that. But when we talk about nutrition, then they're concerned. It means when we talk to solve erosion problem, we need to find another way. We need to, that's what Derek do. That's why our research also mostly related to how to provide nutrition problem to them. And so far, I think the whole world know we have a problem for the price of fertilizer. Then we try to teach them, the farmer, I mean, how to create organic fertilizer, at least to solve some of the fertilizer chemical problem. So far, the government have particular attention to landslide as well as soil. Actually, we work quite a lot with them to create a new regulation, and one is related to pit open, especially as is mentioned to Dr. Brian before. This is the picture of open pit mine in in Morowali Utara, Central Sulawesi, and starting from 1980s, the area become larger, and I think nowadays more than 1 million hectares, something like that, in terms of concession. But the area is still open until now, and you can see the picture there. We use the Google Earth data, and then the right picture is taken using drone. It is very easily, we can see the picture of the problem. Yes, erosion is there. But when we talk about erosion, actually the company or even the farmer do not really get attention to that area. But when we talk about sedimentation to the sea, then we have a problem. And they're really concerned about that. So far we have some research there, and the purpose of the research, of course, to help the government to create a certain criteria that will be applied to the government regulation. This is one of the examples. Of course, there are many criteria to say that one area of bit mine area already have a problem, and we create one of the criteria related to slope instability. Of course, we use quite a lot of data from the field. Then at the end, we combine with all soil and especially public data, digital elevation model. That's the main purpose of this research. At the end, we create slope stability. Of course, we have to make sure the result is better or the model is quite good. Then we make validation using some data from the field. At the end, yeah, the people believe it. But I will believe when we show them the accuracy of the data of the model. So far, the model already now used as one of the criteria to assess the land already degraded, especially related to slope stability in Indonesia. The other thing is our experience. We played about 5 years research project with a partner from SIBA. Indonesia concerned about food security, and we have a lot of problems related to flood, drought, and cross pest and disease. And so far, the way of current guidance is not really applied to the field, and farmers then not really want to follow what government program, especially to insurance. Then in our research, for 5 years research, we create develop new method to assess soil land failure due to flood, drought, and crop pest and disease. So far, we use, of course, satellite data, field data, and using drone. At the end, we create the model, and of course, the final result we create in the books, actually guidance book that we provide to the Ministry of Agriculture. Of course, before this book created, there are several research and publication before we create this one. So far, we already sent these books to the government, and of course, it's being distributed to the whole nation as we call it as just learn it first before putting into regulation. It means our next research is still there, because basically we have a lot of problems related to pest and disease, but we already solved only few. But especially for drought and flood, we will expand also another area as a research area. The other things, as I told you before, when we talk about the soil degradation, people concern more related to nutrition. And even though we create the soil erosion as important parameter, but they do not really concern, especially the farmer. It is a challenge. That's why we start first giving them information about the status of nutrition content of soil. With our cooperation with partner, also with some institution from Netherlands, then again we create apps. Using apps, then we give some recommendation how much fertilization you need if you want to plant a certain horticulture crop. So far, we already reached about 40% of Indonesian area, especially to provide the data. 60% still no data from us, as well as the model for them. We'll create it. At the end, we want to integrate also the model from soil erosion actually. So far, we just create a certain correction factor for giving give them about the recommendation for population. And correction factor actually come from emission, erosion, and other things, something like that. It means there are still some research that we need to conduct, especially to understand the dynamic of nutrition in the soil. So far, we already tried to get some budget, especially from Indonesian, and this kind of activities they already extend for the last 2 years, and this year also we try also to extend. This is the example of the data we put behind our application actually. It means even though we already several series of soil nutrition in the soil, as well understanding the need from the crop, still there are many things to do in our research. Of course, before our application, our apps launched to the farmer, actually we try several field experiments to show the relation between our model with the real implementation in the field. The result is good compared without using our recommendation with what farmer usually do. Our recommendation provide the result. It means what we done in research, when we implement in the field, they accept our recommendation. The last one, actually, I work with Pak Tarigan also. Now the Ministry of Investment and Maritime and Investment in Indonesia invite IPB to involve to help develop food estate in Humbang Kasundutan. The area actually devoted to develop potato and salad area. But if you see the picture, the area is a kind of undulating area with very shallow soil, and they have a lot of problems related also to, I think in the first presentation from Professor Lengelot, we have a lot of problems there when we talk about how to contain related to soil erosion, as well as how to contain water. That's what Tarigan mentioned before. It means we will try actually how to design from the beginning and give the example to farmer the way to manage the landscape, how to handle erosion, how to handle nutrient, how to handle water. And so far, the right picture is what we already make measurement, especially about nutrition content in the area. And I think this area is very open for the research and for collaboration. Besides the other things at the beginning, I mentioned about the open pit mine area that the size become bigger in Indonesia. I think that's the end of my explanation. I invite how to make collaboration in this topic, since we have quite a lot of area that we can make research. Thank you very much.
All right, thank you very much, Dr. Baba, for your very, let's say, very nice presentation. So I would like to open the discussion from the floor, probably some question from the OSU side. Okay, Dr. Baba, I would like to ask just a simple question. There are many things to do bioremediation, especially for open mining area. So what do you think the best, is there any best method to do that, or it has to be a combination of several methods? Please.
Yeah, so far, yeah, you know that I just informed our problem to partners in Indonesia and in IPB. From my perspective, of course, I ask the government use local and economic species actually, because so far they use the standard species from the Ministry of Environment and Forestry, and I know if we use the standard method from the central government, actually it is not really fit with local situation.
Okay, right. Thank you, Dr. Baba. Okay, I see Brian. Brian, would you like to ask a question? So please.
Yes, thanks so much for that great presentation. I was curious on that last slide where there was the sort of land degradation related to the shallot. Those farms are, so is it a process of sort of the nutrients get depleted and then people are expanding into other areas, or are they just having a hard time maintaining kind of the fertility of those sites?
This area previously is not agriculture intensive area. The farmer used for what you call it. Actually, they plant a tree actually, but the government wants to change the quite marginal land to potato area. So the government faced now problem, especially no farmer want to open the area, but the area already open, and they ask private big company to rehabilitate that and use it. That's the current situation.
Okay, thank you very much.
Okay, probably Bu Hanifah, would you like to ask a question? Yes.
Thank you. It's very nice presentation, Dr. Baba. Previously, before I joined to Department of Food Science and Technology, I worked with mycorrhiza group team, research team with mycorrhiza. Actually, mycorrhiza is also important for having the land become productive for can be for forest plants, can be for forest plants, and can be also for agriculture plants. Is mycorrhiza also included in your research?
Yeah, basically, the budget just launched this month. Next month we will go to the field, and actually we will try to build. Basically, we try to design the area first. Then we, of course, we try to learn from because the project already failed for the first and second year. This is the third and fourth year. And the government asked IPB to involve. Basically, from the beginning, we involved second year, but what we recommended, actually they didn't follow. Now they give us the money directly and use it to give the example to the private company and the farmer. That's the current situation. And if you ask how our partner to integrate to the situation, I think next week we will discuss with the coordinator of the team. I think we are welcome to join the discussion, the idea, the research and implementation.
Okay, great. I think, is there any other question coming from the floor? No? Okay, great. So that's all for the today's presentation, because Dr. Baba is the last presenter. So I would like to give back the opportunity to the MC, please.
Okay, thank you very much, Dr. Aziz, and also Dr. Dave for moderating such fruitful sessions with our wonderful speakers, both from IPB and OSU. I also would like to once again thank our honorable speakers for your time to share your research interests and experiences today. Before we end our workshop, I would like to invite Dr. Dave to deliver the closing statement from OSU. So, Dr. Dave, please, the platform is yours.
Thank you very much. I've learned a lot in this session, both from my own colleagues, but particularly from the faculty at IPB. And I came away with even more excitement about the different areas that we can collaborate in. I think Boeing and I have some homework to do afterwards to make sure we follow up with all the contact information between the faculty here so that we can continue this conversation, but also look at real concrete ways that we can fund some of the collaboration that we know is necessary to visit each other, to talk further about faculty exchanges, and to really learn from each other in ways that we can help solve these sticky, complex global issues. So I want to thank all of the folks at IPB that took time to put this together, from the audio visual to assembling all the team. On your end, I want to thank my colleagues for staying up into the evening and participating in this event. And I really hope and look forward to seeing how we work together going forward.
Okay, thank you very much, Dr. Dave, for the remark. Now, I would like to invite Dr. Eva Anggraini to wrap up and deliver some closing remarks from IPB. So, Dr. Eva, please, the time is yours.
Thank you, Nada. I hope my voice is can be heard clearly. Yeah. So I would like to thank you for all presenters. This is really great discussion workshop, and I found that there are various ideas and which can be developed among the researchers, and also from the presentations, I also found that we can also include other experts which has also related to topics that have been presented here. So it will be a richer environment, and I'm really excited to see the follow-up of these activities actually. So I'm here not to wrap up in terms of substancy because it is not my expertise, but as a part of the Director of Global Connectivity, we are here to facilitate all the experts to meet and to match ideas and to develop further ideas. And of course, at the end, we would like to establish new research collaborations or research consortiums among between IPB and OSU. And of course, it is also possible to invite other colleagues from both universities or from other universities. But I think as the leading universities, both of IPB and OSU, I think we are have a good positive energy to initiate our more concrete collaborations on research. So actually, what we can suggest for after the workshop, that of course, first it very much depends on communication between experts. This is very important. So I think from our let's say we have now 5 couples. 5 couples, and I do hope that there will be continued communication among experts And please also involve other colleagues who are working at the same area, so that we can develop, each group can develop, let's say, a topic for future. And also, and after the let's say communication building, we of course would like to facilitate how the group to develop, let's say, to formulate a concept note or to short proposal, so that we can we can follow up, or we can communicate with the ministry or our PDP people, and how this can be funded. And of course, this is not the only, or the only sources of fund. I think we can also opt for other resources, but these are steps which comes to my mind that we can follow up after the workshop. But as I mentioned before, of course, this collaborations really much depends on the engagement or the connectivity among the experts, and this is very important for the follow-up communications among experts. Yeah, so I think we cannot set up that timeline currently today. I mean, because of course it varies among experts, but I don't know if it's possible for us to set up a mailing list, something like that, so where we can involve all of us here, and then people inform each other. And for a more deeper communication, it can be tackle one in person, but at least we are still on the same, or let's say on the same track. We know progress of each other, and this will be yeah, give us also some kind of motivations among groups. So I would suggest this we can organize. So maybe Pak Boying can set up a mailing list where all experts are involved here, if you agree with, and then from that mailing list we can set up a further step, next steps. Yeah, I think for some kind of wrap up, this I mean, like this is a very simple thing that we can organize, and we do hope that that this kind of matchmaking event that we organize today can really at least yeah, can produce some new ideas of research, and we can really propose for some kind of funding and implement the research. Yeah, yeah, I think that's from me, and thank you again for all of the experts from OSU, Oregon State University, Prof. Gail, Prof. Michael, Prof. Jung, Prof. Ford, and Prof. Brian, and also from our side, Prof. Surya, Prof. Hanifa, Prof. Nancy, Prof. Julie, and Prof. Baba. Thank you very much for all the sharing, and we do hope that our communications continue. And also, I would like to thank to all participants who attend this workshop. I hope this gives some insights for all of us. And yeah, we will keep in touch after this. So thank you.
Thank you. And I'm wondering, can we all show our faces and maybe take a quick picture?
Yes, exactly. That's right, Dr. Dave. Thank you.
And
I
forgot to say, this is very important. Thank you, Dev, for all of us. Thank you, Dev and Pak Boying, who initiate this, because this is actually collaboration between. It started from collaboration from Dave and Pak Boying, and we spread it. Thank you very much. Really, very much appreciated.
Yes, now I would like to invite all participants to kindly open your camera so we can take some virtual group photos. Okay. I think we have several slides of participants, starting with the first slide. Put on your best smile. 1, 2, 3. Okay, moving on to the next slide. 1, 1, 2, 3. Okay, I think that's it. Thank you very much, everyone. Ladies and gentlemen, now that we are at the end of our event, I would like to once again thank everyone for participating. I do hope this workshop can be the start of many new exciting collaboration between our universities. So have a delightful day ahead. See you on another opportunities. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Goodbye, everyone.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dave. Thank you for all of our professors. Thank you very much.
Bye-bye.
Thank you very much, everyone.